QM. Okay, so ano lang to? Parang pasadaan lang natin kasi madaming madaming items sa prelim exams na quality management. Okay. Wait lang, hindi na natin pumasok yung iba. Okay. Excuse me. Okay. Okay. So, Total Quality Management or TQM. Okay. So, bakit kailangan pag-aralan ang quality management sa CC and to other sections of the clinical laboratory? Okay. So, we are studying quality management kasi quality is very important in laboratory practice. Okay. Kahit nasa laboratory yung mga recent instrumentation, updated lahat ng machines, ganyan. Pero wala namang quality or walang assurance na steady yung quality. Ibig sabihin nun, hindi magiging maganda yung healthcare delivery sa sa Pilipinas or sa laboratory. Okay? That's why i-implement ang quality management sa lahat ng laboratory nationwide. Okay? So TQM or Total Quality Management process that focuses on improvement of the quality of all factors that affect laboratory testing and performance. There are 5 elements of quality management: the QLP, quality laboratory process; the QA, quality assessment or quality assurance; QC, that's the quality control; QI, quality improvement; and QP, that's the quality planning. Okay. Memorize nyo yan, yung limang yan. Okay, so first, doon tayo sa quality assurance. When we say quality assurance, as the word imply, dapat assured na mayroong quality in every laboratory performance and in every releasing of results. Dapat may quality. Okay? Kasi yung laboratory result from the laboratory will dictate all medical decisions na gagawin ng physician. Okay? So, ganun yung mangyayari. So, QA includes maneuvers encountered in the pre-analytic, analytic, and post-analytic phases of laboratory setting. Ayan. So, yung quality assurance, nahati yan into 3 phases. Okay? So, later we will discuss that isa-isa. It monitors quality performance starting from the ordering of laboratory determination. Ordering of a laboratory determination ba to? Parang parang typo lang yan. Ordering of a laboratory test. So it's reporting, the interpretation of results, and then application to patient care. Ayan. So dyan nag-rotate ang QA. Okay? Para assured na merong quality. Ibig sabihin nun, kapag merong quality yung laboratory result, mas maganda yung healthcare delivery ng healthcare team. Okay? So the physician will have a good medical decision. The pharmacist will give the appropriate drugs, mga ganyan. Okay? So nag-uugat lahat sa laboratory. Kasi according to Henry's, 70% of medical decision is happy. 70% of medical decision will happen after a laboratory result. Ayan. So, ganun kalaki ang role ng mga medtech sa healthcare team. Kasi tayo yung parang bulk na na contribute sa patient wellness. Okay? So 70% of medical decision happen in the laboratory or after obtaining a lab result. Okay? So ganun siya. Okay, so pre-analytic phase. When we say pre-analytic phase, this is the phase before a testing method. Okay? So ano yung mga pre-analytic phase natin? Medyo madali na lang siyang intindihin. Basta ang isipin ninyo, before the testing, before the process, this is all the variables in the pre-analytic phase. Okay? Test ordering by the physician, specimen collection by the medtech or by the nurse. Okay? Guys, as a hospital, hindi lang medtech ang nagko-collect ng sample. Sometimes, lalo na kapag stat yung request, ibig sabihin ng stat, tawag dito, yung kailangang mabilis yung result within 1 hour, dapat meron ng result. Sometimes, the nurses in the ward are responsible for blood collection also. Pero, hindi lahat ng nurses, hindi lahat ng nurses merong certification sa phlebotomy. They need to undergo a training para mabigyan sila ng certificate, especially when they are working in a tertiary government hospital. Okay? Ganun yung ginagawa ng mga nurses. Specific transport to the laboratory. Ginagawa yan ng mga laboratory aid, ay ginagawa yan ng mga nurse aides, ng mga nurses, ng mga respiratory therapists, ganyan. Sila yung nagtra-transport ng request. Okay? Processing the specimen and logging. Upon receiving of the specimen, in some hospitals, in San Lazaro kasi we have lab aids. Okay? So yung mga lab aids na yon, sila yung nag-receive ng specimen and then sila yun din yung naglalag ng specimen and then yung request. So kapag nilalag yun, yung name ng patient, yung test, and then yung date and time ng receiving. Okay? That's why we have a section in the laboratory called RR. RR means receive release section. Okay? Nag-rotate din doon yung mga interns. In Bulacan Medical Center, they have this section called PR, phlebotomy and releasing. Yan. Parang pare-parehas lang din yun. Sa RR din nangyayari or sa receiving releasing yung phlebotomy area. Entering the patient info. Entering the patient info in the LIS or the Library Information System sa hospital. I think na-discuss nyo na partially ang HIS or Hospital Information System together with the Laboratory Information System or LIS sa hospital. Ito kasi yung parang network sa buong hospital in which the record of the patient is there, the request, the results are there, ganyan. So that's the patient info. Since medyo automated na yung mga instrument natin today, upon entering the patient info, you can now get e-barcode. Okay? Binabarcode na lahat ng ngayon ng mga specimen. Okay? Kapag na-enter na yung patient info, lalabas yung barcode. So after entering, barcoding na next, and after barcoding, dindikit na yung barcode sa may sticker siya, dindikit sa may tube or sa any other And then, pag pinifig yung instrument, meron ng scanner yung instrument, and upon scanning the barcode, the instrument will know what specimen that is. Okay? So, ganun mangyayari. Centrifugation. Pag-take note itong centrifugation and separating and aliquoting plasma. Okay? Take note. Kasi parang part na sila ng process, but they are not on the analytic phase. They are still on the pre-analytic phase because they are part of the specimen consideration. Okay? Centrifugation, it is a separation technique. Separating and aliquoting plasma. Tawag dito, ayun din, separation technique din. Separating and aliquoting, yung magpipetting din yan. Aliquoting means you're going to aspirate a volume from the specimen to a receptacle. That's aliquoting. Okay? Part ng aliquoting, kapag mayroong fibrin yung specimen, you need to press the fibrin to extract the serum. So they are all part of the pre-analytical phase. Okay? And delivery to proper laboratory location. Yeah. So that's also part of the pre-analytical phase. there are some laboratory kasi na hindi centralized lahat ng testing. Okay? For example, in San Lazaro Hospital, in the main laboratory, ang meron lang doon, it's release receiving, CC, HEMA, CM, and IS, or zero. Zero pala, zero and zero. Separate building ang bacteriology, separate din ang building ng DSSM or direct sputum smear microscopy, separate building din ang TB bacteriology, separate building din ang STD serology, ganon. So basically, it's hindi isang building, okay? So nagkakaroon ng problem minsan sa delivery sa specimen delivery ng mga nurse aid, ng mga nurses. Kaya minsan nagkakandawalaan yung mga specimen, ganyan, yung mga request kasi wrong laboratory location, yung mga nangyayari. That's why dapat oriented lahat ng mga hospital personnel kung para saan itong ganito so it can be received in a proper building. Analytical phase. Okay, so when we say analytical phase, this all include all the process. Okay, so from the testing, from the determination, from QC, from running controls, from calibrating of instruments, and record keeping. Okay. So, commercial control, calibrators, and standards. Bakit nasa analytical phase siya? Later, we will discuss that running of controls must be done in adjacent with the patient sample. Okay, ganun yung mangyayari. And record keeping, pag i-take note ito, medyo confusing siya kasi when we say record keeping, parang hindi naman siya part ng analytical phase. It's more like parang post-analytical siya. Pero record keeping kasi once the results are out in the machine, the results are recorded instantly. So basically, they are part of the analytical phase. Okay. So next naman is post-analytical phase. This phase is is also crucial sa QA. Okay. So reporting of specimen results, physician contact, and reference ranges. Okay. So reporting of specimen results. All specimens must be reported in writing or in prints. Okay? Hindi pwedeng itinatawag yung resulta sa nurse ward. Hindi pwede yun. Okay? For reference ranges, dapat all meaningful laboratory results must be accompanied by the reference ranges or the normal value. For example, for FBS, ganyan. Yung FBS ni patient, kasi diabetic siya, umabot ng 140. Yan. So, for example, sa left side, nakalagay doon yung result niya like 140 milligrams per deciliter. And then, just beside that result is the reference range or the normal value or the normal range, which is 90 to 110 milligrams per dl. Ganyan. Kasi guys, hindi naman lahat ng doctors natin medtech ang pre-med. Okay? At para to help na din the physician to interpret the results clearly. Ganyan. So, para malaman nila na masyadong mataas or masyadong mababa or above the upper limit or below the lower limit yung result ng patient. Mas maganda na lagi nakalagay and it is recommended na lagi nakalagay ang reference ranges beside the laboratory result. Okay? That's very important. Okay. QC. Concerned with the analytic phase of quality assurance. Ayan. Ang QC, embedded siya sa QA, doon sa analytical phase. Kasi doon yung running ng controls, doon yung running ng calibrators and standards. Okay? So a system of assuring accuracy and precision in the laboratory by including quality control reagents in every series of measurement. Ayan. So in the hospital or in the clinics, running of controls must be at least once a day. Ayan. Once a day or per shift or in every shift dapat nag-run ng control. Nirun ng control in times na medyo benign yung duty. Doon nag-run ng control, yung mga staff medtech sa hospital, ganyan. So usually mga late late night, sa mga madaling araw, dun sa nagawa ng control. Ganyan. Okay, so when we say controls kasi, when it says assuring accuracy and precision, running these types of solution in the machine validates the results of the machine. Ayan. Kung tama yung binabasa ng machine mo, ibig sabihin nun, kung tama yung binabasa ng machine, dapat correlated siya sa values na nakukuha niya sa control solutions. Okay? So the process of ensuring that analytical results are correct by testing known samples that resemble patient samples. Overview. Ano yung itsura ng control sample sa HEMA? It's color red. Parang blood din siya. Control sa CC, it's yellow. Parang serum din siya. Control sa CM, yellow din with different color gradient. Kasi nga parang urine. Huwag niyo kakalimutan yan. Parameters of quality control. Okay. So when we say parameters of quality control, dapat meet lahat ng parameters na to so we can establish quality. Okay? So first one, analytical sensitivity. Paano ba ito nalaman when we say analytical sensitivity? The ability of an analytical method to measure the smallest concentration of the analyte of interest. How sensitive is your test with the analyte? Okay. So there are some kits or some tests. They only have the sensitivity range or sensitivity index in which they can detect this analyte at this certain level only. Ayan. For example, sa routine sa urine reagent strip ganyan. Okay. So sa routine reagent strip, if I'm not mistaken, chem strip or multi-stakes, hindi ko na masyadong matandaan. They can only detect 5 milligrams. I mean, yung kanilang sensitivity for protein is 5 milligrams yata. Ibig sabihin nun, kapag 5 milligrams above yung analyte na present sa body fluid, magpa-positive sa parameter na yon. Okay? Kapag naman 4 milligrams or below, magne-negative na yon. Okay? So when we say sensitivity, gaano ba ka-sensitive? Or at what level of the analyte para ma-detect ng isang test. So that's analytical sensitivity. Okay? Next naman, specificity, ability of a method to detect only the analyte designed to determine. Ayan. All tests must be specific. Okay? Since our body fluids are solutions, kapag magde-detect ka ng glucose sa serum, hindi lang glucose ang meron sa serum. Okay? The test must be specific enough to detect only the glucose and not other analyte. Okay? So, ganun ang specificity. Dapat specific siya. We have this principle in body fluids called matrix effect. Okay? Yung matrix effect, parang part siya ng interferences. Naka-bracket siya under interference. Okay? Ibig sabihin lang nun, that the composition of the solution or the composition of the body fluid can influence the results upon testing. Ayan. So, dapat specific yung method nyo. Dapat kahit madaming solutes, dapat yun pa rin yung nadidetect niya. Kasi kapag yung test mo kasi is sensitive din to analyte na hindi, for example, na hindi glucose din, yung possibility ng overestimation is mataas. Okay? So, ibig sabihin. Accuracy and precision and accuracy, nearness or closeness of the value to the targeted value. When we say precision naman, this is the precision or reproducibility. Ibig sabihin nito, kahit paulit-ulit yung testing, magkakalapit pa rin yung result. Okay? Kahit ako, for example, dalawa ang duty na medtech sa clinic, ganyan. If the first medtech, tinest niyo yung isa, tinest niyo yung method, and then the second medtech, test it again, parang malapit lang yung kanilang resulta. Ayan. So, how can we interpret precision and accuracy? Okay, so, based on a diagram, ko lang na nalagay dito. Dart. You know the dart? Yung merong bullseye, yung red na bullseye, yung dart. Okay. When we say accurate, dapat yung dart nasa bullseye. Okay? Yung isang dart dapat nasa bullseye. That's an accurate presentation. When we say precision naman or reproducibility, let's just say there are three darts or three tests. Okay? That the three darts are close to each other but not necessarily nasa bullseye sila. Okay? So they can be anywhere on the board basta magkakadikit sila. Okay? So dito na papasok yung ating reliability. Okay? When we say reliability, this is accuracy plus precision. If the test is precise and accurate, it is reliable. Okay? So ganun mangyayari. So nakalagay dito, three bullseye. When we say three bullseye, ibig sabihin nun, it is accurate and it is precise at the same time. That's why it is reliable. Okay? So the ability of an analytical method to maintain accuracy and precision over an extended period during which equipment, reagents, and personnel may change. Ayan. So dapat accurate palagi yung ating resulta para magandang takbo ng healthcare. Okay? Next naman, practicability. When we say practicability naman, degree by which a method is easily repeated. Ayan. So, practicability today ay achieve na natin. Bakit achieve na ang practicability ng most testing today? First one, automation. Automation is one of the factors considered at naging practicals ng mga testing natin. Automations, kits, mga rapid test, yan, yung mga practical modalities of testing. Okay? So, bakit nga ba kasama siya? Kasi when we're going to compare automation and manual method, for example, nung hindi pa usang Victros for Chem, syempre gumagamit sila ng naghahalo pa sila ng reagent, ganyan, like yung gagawin natin later sa face-to-face. Maghahalo pa kayo ng reagent, and then mix-mix nyo pa, ganyan, and then iyan nyo pa sa spektro, ganyan. In which, kapag yun ang ginagawa sa hospital na sobrang daming patient, sobrang daming specimen, it's not very practical at all. Kawawa naman yung mga medtech na magmamanual method for example, magmamanual method ka ng magmamanual method ka ng morning peak specimen. Baka alas 12 ka na ng tanghali matapos sobrang dami ng manual mo. Kapag kasi machine, kits, ganyan, mabilis lang yun. Okay? Okay. Practicability. Ayan. Diagnostic sensitivity and diagnostic sensitivity, part pa din ito ng QC. Okay? So, dalawa. When you say diagnostic sensitivity, the ability of the test to detect the proportion of individuals with the disease who test positively with the test. Okay. Guys, diagnostic sensitivity and specificity, part siya ng kit evaluation or test evaluation. Okay. This type of equation, malalaman natin if the test can really detect the analyte of interest. Okay? Kung yung test na to, na talaga bang na-detect niya yung analyte na meron sa patient na merong clinical condition. Kung yung test ba na to, na-detect niya yung mga analyte of interest. Okay? So part siya ng test evaluation. Kung gaano ba ka-sensitive yung test, kung gaano ba ka-specific yung test, ganyan. Okay? So for the sensitivity equation, the number of the disease individuals with a positive test over the total number of disease individuals tested. Ayan. So for it to make 100%, just multiply it to 100. Ayan. So for sensitivity, the true positives or the TP divided by the true positive plus false positive, or ito yung total number of disease individuals tested, multiplied it to 100% para makuha mo yung percent sensitivity. Ayan. Okay, so later on, kasi guys, mamaya ko na lang share. Ayan, diagnostic sensitivity. Okay. The ability of the test to detect the proportion of individuals without the disease who test negatively for the disease. Okay. So for diagnostic sensitivity, a positive, ang tawag dito? With the disease. Proportion of individuals with that disease. Proportion ito naman negative is diagnostic specificity, proportion of individuals without the disease who test negatively for the disease. Okay? Lagi itong lumalabas sa comprehensive ni Ma'am Sheila. Okay? Lumabas to sa comprehensive Ma'am Sheila. Lagi lumalabas kapag sinabing specificity without the disease negative. Kapag yung sensitivity with the disease positive. Ayan. So ang ibig sabihin ng diagnostic specificity, dapat negative siya kung walang sakit yung patient. Kasi may mga instances kasi na nagpa-positive yung kit pero wala namang sakit yung patient. May mga instances na nagne-negative yung kit or yung test pero meron namang sakit yung patient. Ano? This parameter will evaluate the test. Ganyan. Okay? So for the equation, true negative divided by true negative plus false negative or the Fn. Okay. So ganito. Okay, share ko na. Okay, so if you happen to be an intern of San Lazaro Hospital, since it's a reference laboratory, ibig sabihin nun, it is a reference laboratory for STD and AIDS. Okay, yung main lab, it has a separate rotation. Yung mga sections yung mga major sections like CC, Him, IS, ganyan. For the SACL, doon sa mismong reference laboratory, yung mga interns doon, meron ding rotation din doon. So bali dalawang rotation yung mangyayari. Hindi siya yung parang normal na internship na isang rotation lang sa isang main laboratory. Mag-rotate din kayo sa SACL or sa SACL. Ano ba yung SACL ulit? STD and AIDS Central Cooperative Laboratory or SACL. There is a rotation there called kit evaluation. Okay, so hindi lang kit evaluation. Yung mga rotations na like kit evaluation, hepatitis, syphilis, viral load, HIV, hepatitis, CD4 count, filing, ganon. Itong topic na to, na-encounter yan sa kit evaluation. Ano ba ginagawa sa kit evaluation? Lahat ng test kits na ginagawa ng mga manufacturer for hepatitis and HIV, kailangan mo nang dumaan ng SACL para i-evaluate yung kanilang specificity and sensitivity. Okay. Ang ibig sabihin lang nun, kapag hindi pumasa sa evaluation yung kit na yon, hindi siya i-release ng FDA as a good. Okay? Hindi siya pwedeng i-release ng Food and Drug Administration, yung kit na yun, kung bagsak siya sa evaluation. Paano ginagawa yung kit evaluation? Okay. Ito yung nakakangalay na ginagawa ng mga intern doon sa akin. Yung manufacturer, magbibigay sila ng kit sa SACL, and then the interns, bubuksan nila lahat yung sobrang daming kits as in nakalatag lahat sa may bench. And then, yung mga HIV positive plasma or serum obtained from HIV patients in San Lazaro Hospital, yun yung ginagamit na control solutions sa kit evaluation. So, sure na positive yung body fluid na yun. So, mangyayari, yung intern, papatakan niya lahat na positive serum yung mga kits. Okay? So, tapos, kung nag-positive, okay, nakakabasa tong kit na to. There are instances na parang may mga kits in the batch or in the lot or in the test kit or in the batch test kit na may mga nagne-negative kahit positive naman yung serum. Okay, so ililista yun sa false negative. Ganyan. So, yung mga true negative, yun yung mga nag-positive sa kit na pinatakan ng HIV positive specimen. Tapos yung mga false negative, yun yung mga kit na pinatakan ng HIV positive specimen na nag-negative sa kit. Okay, ganun yung ginagawa. Same, ano lang siya, parang Counterpart lang siya ng ano, ng diagnostic specificity. Okay? I-run din yung mga serum i-run din yung mga kits sa normal serum. So kapag masyadong madaming false negative, or masyadong madaming false positive sa kits or sa test or sa kits, for example sa SACL, babagsak yung evaluation sa kit. Ang mangyayari, hindi bibigyan ng permit, yung manufacturer to produce this kit that can be disseminated nationwide. Ganyan. Kasi yung mga nakikita niyo yung mga kits dyan, yung mga hepatitis, HIV, dumadaan lahat yan sa SACL bago pumunta sa consumer or sa mga sa mga satellite laboratories nationwide. Ganon. So that's a practical example of test evaluation using diagnostic specificity and sensitivity. Okay. We have a problem here. A new cancer antigen 125 test for ovarian cancer gave positive results in 21 of 24 malignant patients and negative result in 61 on 62 benign patients. What are the sensitivity and specificity values? Okay. If you are given this type of problem, you just need to determine the variables here. Okay? Yung mga TP, FP, TN, FN, ganyan. True positive. Okay. Give positive results in 21 of 24. Okay, so 21 yung true positive, 3 yung false positive. Okay. Next one, true negative, 61, false negative is 1. So basically, you have 62 patients here. Okay. So ipa-plot mo lang, ipa-plot mo lang yung value sa equation, like for example, for sensitivity calculation, you're just going to plot the true positive divided by the total. Ganyan. So 21 divided by 24 is equal to uh, 0.875 times 100, that's 87.5. Ayan. So same lang din sa size specificity. Ganon din, plot mo lang. Dito, based dito sa result ng cancer antigen 125 na test kit, yung sensitivity niya medyo mababa. 87 lang yan. Medyo mababa siya. Yung specificity, mataas-taas na din yan. So, ibig sabihin nito, the test is specific but not reliable. Okay? Ganun siya. Okay? So that's how you interpret the evaluation on the test. Okay? Ginagawa yan ng mga medtech. Okay? Yung mga medtech, hindi lang basta memorize, you need to understand everything. Okay? Ganyan. Okay. Kinds of music. Guys, wait lang, 5-minute break. Medyo masakit lang muna. Inom na ako ng tubig. Okay, let's resume. Kinds of QC. We have two types of QC. Okay, internal and external. Okay, let's discuss first the internal QC. When we say internal QC, this type of quality control happen within the vicinity of the laboratory. Okay, so the internal QC is also termed as intralab QC or internal QC. Okay, so from all the description included in the intralab, it involves analysis of control samples, involves the analysis of control sample together with the patient specimen. Okay, so sa intralab QC, ito yung mga process na ginagawa sa laboratory from running of QC, from calibration of instrument, calibration of pipettes, calibration of centrifuge, calibration of machines, calibration yung mga temperature controls ng mga ref, lahat yon, they are all part of quality control. Okay? Yun, daily monitoring of accuracy and precision as well, detects random and systematic error, but it is a measurement of short-term accuracy. Okay? This is one of the most notable description of intralab, a measurement of a short-term accuracy. Okay? Bakit nga ba short-term accuracy lang ang intralab? Okay, let's proceed to the external QC. When we say external QC naman, it is also termed as the interlab QC. Okay? So, when we say interlab QC, ito yung ginagawa naka-umbrella ang interlab QC sa proficiency testing. Okay. So for proficiency testing, ang ginagawa diyan, parang bina-validate or tinitest ng reference laboratory yung isang laboratory if the results are reliable. Okay? Diyan nila tinitingnan. For example, yung mga proficiency, yung nagka-conduct ng proficiency testing, ito yung mga reference laboratory. For example, proficiency testing for HIV, hepatitis, syphilis, and STD, nangyari lahat yan sa SACL. For proficiency testing in bacteriology, ginagawa yan sa kinakandak yan ng RITM. For proficiency testing ng micronutrients and related analytes sa East Avenue Medical Center. For proficiency ng hematology, ginagawa yan, kinakandak yan ng NKTI, mga ganon. Okay. So, it is important in maintaining long-term accuracy of the analytical method. Kasi once na pumasa yung isang laboratory sa proficiency testing, ibig sabihin nun, the testing of that laboratory is reliable. Okay? So, ganun yung ibig niyang sabihin. Okay? Monitors primarily the accuracy of the laboratory test. It is also used to determine estimates of the state-of-the-art inter-laboratory performance. Ayan. So yung pagconduct ng proficiency testing, parang partly benchmarking yung nangyayari. Ibig sabihin nun, the reference laboratory is comparing the results of one laboratory to the other, ganyan, in a SB na yung mangyayari. Okay. So let's go to the proficiency testing. Okay. Proficiency testing. Okay. Sa na-encounter ko din ito since yung SACL, nagkakandak sila ng proficiency testing annually. Every year dapat nakiki-cooperate yung isang laboratory sa proficiency testing para mabigyan sila ng LTO or license to operate. Okay? Parang part siya ng license requirement ng DOH and NIH para mabigyan ng license to operate yung isang laboratory. Kasi kung bagsak sila sa proficiency testing, mangyayari hindi sila mabibigyan ng license. Walang license, di mag-operate nila yung laboratory, na ibig sabihin. In a summary, sa paggandak ng proficiency testing, ang nangyayari diyan, the reference laboratory will send out body fluid with a known concentration of analyte, and then itetest yan ng isang laboratory and the results are forwarded to the reference laboratory. Kung malapit or exact yung na-measure ng isang clinical laboratory compared to the values obtained from the reference laboratory, ibig sabihin nun, the results or the testing is reliable. Ganun na yung pinaka-summary ng proficiency testing. Okay? I guess na-encounter nyo na ang proficiency testing sa medtech law kasi dinidiscuss din sa medtech law ang proficiency testing doon sa licensing ng isang laboratory. Okay? So, ganun yung ibig sabihin. Okay, so ayun lang. Nasabi ko naman na dito yung sinabi ko kanina. The target values and ranges of acceptable results based on the reference laboratories or on the average participating values are established. Okay. Participants are graded by deviation of the results or SD. Okay, dapat magkakalapit lang. Okay, ganun yung ibig sabihin. For example, there are 5 participating laboratories. And then yung isa, 5 participating laboratories, and then the samples forwarded to the 5 are the same aliquots in a same specimen. Tapos yung 4 na laboratory nasa around 1 SD sila, magkakalapit lang. And then yung isang laboratory nasa 3 SD na or nasa 2 SD. Ibig sabihin medyo outlier yung resulta ng isang laboratory. Yung ibig sabihin nun, that one laboratory hindi reliable yung kanyang testing process. Kaya pwede siyang hindi mabigyan ng certificate for the testing, or that laboratory can apply again for a proficiency testing on the next cycle. Okay, so during my rotation sa SACL, yung section doon na filing, there is a filing section sa SACL. So andun lahat ng mga laboratory nationwide na nag-apply for proficiency testing. Na-encounter ko yung laboratory dito sa Bayombong. Nag-apply sila for hepatitis dito sa NVMMC. Dito sa may malapit sa Moorwood, sa may Latin Bright Child, yung lab dyan. Nakita ko din ng NVPH, nag-apply din sila for hepatitis and HIV. And also for also the R2DMC or veterans, din sa veterans, nag-apply din sila ng HIV and hepatitis. Ayan. So yung ginagawa ng intern sa filing, kapag nagsasabit yung mga hospital ng request na ginagawa ng interns, parang inaayos nila yung files, tinitingnan nila kung kumpleto, tinitingnan nila if kumpleto, and then once na complete na, parang ina-arrange ng intern alphabetically yung mga clinics and hospitals na nag-apply. So medyo stressful itong section na to sa akin. Variations of errors. Okay. Why do we need to study and know errors in the laboratory? Okay. Guys, kasi lahat naman ng process, there are rooms for error. Lahat merong error mangyayari. Kahit gaano ka-control lahat ng ginagawa sa laboratory, there are still errors. Okay. Pero bakit kailangan natin malaman yung error? Knowing the error itself help you how to prevent them or prevent from causing them. Yan. So, para studying errors is just the same on how to prevent from causing it. Parang ganun. Okay? So, variations of error. All laboratory analysis are subjected to analytical biases, random analytical variability, and errors. Okay. Kasi guys, sa testing process, hindi lang naman sa method nangyayari yung error. For example, mali yung pipette ganyan. There are many factors that can present error in quality management. Okay. So we have 2 major types of errors: the random error and systematic error. Okay. So when we say random error, these types of error happen randomly. Kaya nga sinabi siyang random error, di ba? So ito yung mga error na nangyayari unexpectedly. Ito yung mga error ito yung mga error that cause outlying of results. Ito yung mga errors na nangyayari na walang trend or walang pattern Ganon. Random lang siya. Okay? So it can be both positive or negative. These types of error can either underestimate or overestimate laboratory results. Ganyan. Okay, so what are the ano tawag dito? What are the examples of random errors? Okay, instrument, operator, and environmental conditions like temperature fluctuations. Okay, so temperature fluctuation. Temperature is very important in the clinical laboratory. Okay, kaya yung mga tawag dito, sa mga clinics and hospitals, kung napapansin ninyo, malamig doon sa mga hospitals and clinics, sa clinical laboratory or sa Department of Pathology. Okay? Bakit malamig sa loob ng laboratory? Okay? Because the machines are the machines must be exposed to a certain temperature only. Kasi yung mga machines sa laboratory, especially kapag hospital yan, the machines are running 24/7. Ganun yung mga machine doon. Hindi siya in-off. As in, 24/7 nag-run yung mga machine. That's why they are very prone to overheating. Kaya malamig sa laboratory. Madaming aircon sa laboratory. Okay? Ang ginagawa nga dito, per section, tig-isang aircon. Ganun yung nangyayari. And sa laboratory pa, some sections ay nakalagay sa isang cubicle or nasa isang room. So basically, yung kapag binuksan yung mga sa main laboratory, sobrang ginaw talaga. And kapag mag-i-install ng bagong machine, the laboratory needed to install one aircon for that machine para ma-maintain yung temperature sa loob ng laboratory. Okay. So ang nangyayari kasi dito, if the temperature requirement is not met, magkakaroon ng temperature fluctuation, madi-disturb yung running ng machine, magiging erroneous yung result nila. Okay. But this temperature fluctuation is parang na-prevent na siya because there are machines, for example, Vitros and Sysmex. Sysmex in Hima and Vitros in CC, nag-a-alarm na sila kung medyo mainit yung laboratory, like mag-iingay yung isang machine kung mainit yung laboratory. Kaya minsan ang ginagawa kahit naka-aircon na yung lab, meron pang electric fan sa likod ng machine para hindi mag-alarm. Tutunog kasi ng malakas yun, mag-alarm kung medyo mainit na. Okay. That's why some hospital personnel, sa mga wards ganyan, nagreklamo sila, lalo kapag public hospital. Kasi sa public hospital, yung mga wards, walang mga aircon yan. Ibig sabihin nun, kapag tanghali, sobrang init talaga sa mga wards. Ang sinasabi nila, bakit yung mga medtech daw, nasa loob lang naman sila ng laboratory, tapos ang ginaw-ginaw daw, ang lamig-lamig, tapos wala naman daw silang ginagawa, ganyan. Tapos, hindi naman mga medtech ang pinapalamigan doon sa laboratory, yung mga machine. Okay? Lalagay niyong isipin yon, hindi tao ang nakikinabang sa aircon ng laboratory. Ang machine ang merong requirement sa malamig na temperature. Kaya, you must know how to defend yourself in case you've encountered that kind of case. Okay? So what are the examples of random error? Mislabeling the specimen. Pre-labeling. Nilabel na agad ng intern or ng medtech yung tube, and then upon labeling, nag-collect siya. Yun pwede, delikado yun. Kapag kasi nag-ward kayo, tapos masyadong madaming specimen, madaming request, tapos puyat pa kayo dahil sa night duty, wala na, mapagbabali-baliktad niyo yun. And that is a ground for mislabeling. Okay? Delikado yun. Kapag kasi nagkaroon ng mislabeling, though tama yung process, pero the results are erroneous to that patient. And then, the medical decision of the physician will be correlated with the lab result. Ang mangyayari, mali yung maibibigay niyang medication sa patient. Kung mali yung maibibigay ng medication, mangyayari, pwedeng maging critical yung case ng patient. Okay? So, analytical result is assigned to wrong specimen. wrong number entry on the test result. Itong dalawang ano na to, itong dalawang example na to, medyo naiwasan na yan, yung result assigned to wrong specimen. Kasi, automation na. Upon barcoding kasi, ando na yung identification. And then kapag finid yan sa machine, na-identify na ng machine yung specimen, and then diretso result na yon. The results are are to the specimen only na na-scan ng machine. So medyo naiwasan na yan. Okay? Typeting error, temperature fluctuation, improper mixing of samples and reagents. Prone itong example na to sa manual methods. Same lang din dito sa apat na to. Na-encounter to sa manual method. Typeting error, for example, kasi sa CC, sa hospital or sa clinic, hindi naman na usually magpapipet, buhos-buhos na lang ganyan. Improper mixing of samples and reagents. Again, sa ano na yan, sa manual. Hindi naman na tayo nag-mix ng reagents sa laboratory. Okay? Kasi sa laboratory kasi, more like ano na doon, dry chemistry. Later on, we will discuss dry and wet chemistry. Kapag sinabing dry chemistry kasi, na ginagamit sa vitros, yung machine for CC, cartridge na lang siya. Cartridge na pinapasok sa machine. Pero there are examples of wet chemistry. For example, human star machine sa chemistry. Ang ginagawa doon, yung medtech pa yung naghahalo ng mga reagent, tapos yun pa yung binubuhos sa machine. Pero hindi siya commonly ginagamit. Mas practical gamitin yung dry chemistry compared sa wet chemistry. Yun na. Systematic error. When we say systematic error, this type of error shows a pattern. May pattern yung error na to. Okay? May pattern, may trend yung error. Okay? Yung error parang hindi nag-deviate, yung error parang isa lang yung itsura. That's a systematic error. Okay? So, same lang din with the random error. It can be either positive or negative bias. Errors that influences observation consistently in one direction. Ibig sabihin ng one direction or merong constant difference, merong trend. Ibig sabihin, papataas ng papataas yung nababasa ng machine or pababa ng pababa yung nababasa ng machine. Paano yan ma-determine? Dito sa examples niya. For example, determination of reagents and control deterioration of reagents and control materials. Kapag nag-deteriorate yung isang reference material like control and standards, ang mangyayari, the potency of the solution is also deteriorating or bumababa. So, ibig sabihin nun, pwedeng laging tumataas or papataas ng papataas or pababa ng pababa yung result ng isang test kasi nag-deteriorate yung isang reference material. Okay? Ito. Calibration problems, failing instrumentation. Okay. Si MedTech, parang tinatamad na siyang mag-calibrate ng instrument. Hindi na siya nag-run ng standard. Ang ibig sabihin lang nun, the machine is not reading the specimens correctly. So, ang ibig sabihin nun, it can also show trends. Pababa ng pababa, pataas ng pataas yung value. Pero, kapag tinest yan in a well-calibrated instrument with fresh batch of control solution, nagdi-deviate. Parang there are results na medyo mababa, na mataas, nasa normal, mababa, mataas. Dapat nagdi-deviate siya. Pero kung yung result ng machine is nasa 1SD, laging pumupunta sa may 3SD, pababa ng pababa, or 3SD papuntang 1SD, pababa ng pababa, that is a ground for systematic error. That's why in your module, we will discuss later yung multi-rule ng Shewhart. Doon madidetect yung mga errors na ganito. Okay? So, poorly written procedure is very important. Guys, kasi even though we have the same principles in all testing. For example, yung principle ng cross-matching, isa lang yan sa lahat ng laboratory. Yung principle ng glucose oxidase, isa lang yan sa sa lahat ng laboratory. Yung principle ng Hagedorn-Janssen or yung reverse colorimetric for glucose, isa lang yan sa buong laboratory. But for standard operating procedure, magkakaiba sila. SOP or Standard Operating Procedure, ito yung protocol na fina-follow ng isang laboratory. For example, si Laboratory 1 and Laboratory 2, they both utilize glucose oxidase for their glucose determination. Pero si Laboratory 1, it uses a smaller volume requirement kasi ito yung requirement ng reagent na binibigay sa kanila ng manufacturer nila. Si Laboratory 2 naman, mas madami yung volume niya sa sample kasi yung manufacturer niya, ito yung kanyang protocol. Okay. So the SOP is highly dependent on the manufacturer's package insert or the manufacturer's procedure or the manufacturer's protocol. Doon naka-base. Though para sila ng principle, magkaiba sila ng procedure kasi magkaiba sila ng, for example, ng reagent requirement, ng volume requirement sa testing. Okay? So, paano kung okay pala ito. Before you will rotate, after your rotation exams in internship, diba, for example, tapos ka na mag-CC sa internship, mag-clinical chem sa internship, you will now go to hematology. Ganyan. Before you do any procedure in hematology, ask for your section head kung nasaan po yung SOP or yung Standard Operating Procedure. Parang i-scan nyo lang. Basahin nyo yung SOP. Kasi kapag meron kayong mga seniors doon or yung mga intern na tapos nang mag-hematology, pwede kayong magpaturo sa kanila paano gawin yung SOP or you can just read the SOP alone. Either way, okay lang din. Paano kung si MedTech? Parang nahirap man siya i-comprehend yung procedure kasi si section head, yung pagka-encode niya ng procedure, medyo magulo. Hindi maganda. Kasi mako-confuse si MedTech. Kapag na-confuse si MedTech, yung pagkakaintindi niya sa procedure, yun yung ia-apply niya sa lahat ng hawakan niyang specimen. Okay. By the way, section heads yung gumagawa ng SOP. Section heads yung gumagawa. Okay. So, si MedTech, yung pagkaintindi niya sa SOP, yun na yung gagamitin niya for the rest of the duty or for the rest of her or his rotation in the section. So, ano mangyayari? Kung mali yung pagkaintindi niya, mali yung gagawin niyang method, ibig sabihin nun, kung mali, the results are the same. Walang deviation. Same lang din yung result na ma-obtain niya kasi mali yung procedure. Kapag mali yung procedure, it can either be walang mangyayaring reaction, kaya parang stagnant. Nagiging stagnant lahat ng resulta. So that is a systematic error as well. Okay? So ganun yung nangyayari. Okay? For poorly written procedure. Okay, so systematic error may be proportional bias, slope or percent error. Slope is not equal to 1. The reported values are higher than the expected values. Results in greater deviation from the target value due to higher sample concentration. Exists when the difference between the test method and the comparative method values are proportional to the analyte concentration. Dito tayo sa last statement. Systematic error may be exist when the difference between the test method and the comparative method values are proportional to the analyte concentration. So, ganyan yung ibig niyang sabihin. Kapag ano daw, ayan. Wait lang. Meron mnemonics dito, be. Wait lang. Parang nakalimutan ko na yan. Yung mnemonics dito. Slow proportional. May mnemonics dito, eh. Parang spicy yata. Spicy yung mnemonics dito. Slow. Ano tawag dito? Spicy. Forgot. Spicy. Basta yung ano dito, basta yung parang spicy, slope, tapos may one, yung I don't want, or spicy. Later, check lang sa GC, umanong ko yung notes ko doon sa pneumonia. Parang may spicy yung ano dito eh, parang hindi makalimutan. Kapag systematic kasi, tapos proportional, the slope is not equal to 1 or dash na may ganon. I mean equal sign na merong. Basta not equal to 1. That's spicy. Okay. Basta i-memorize nyo to. I-discuss ko sana yung graphing neto, pero sa lecture kasi siya ginagawa, hindi sa laboratory. Baka i-discuss sa inyo ni Sir Ronnie. Basta yung lingmosil is spicy. Ayan. So, dalawa pala yung types ng systematic error, the proportional bias, kaya yung last statement. Okay? The proportional yung test method sa comparative method. Yung difference niya is proportional. Ibig sabihin nun, for example, si comparative method or the reference method, tapos si test method, kapag nirun mo siya 7 times, yung 7 replicates na yon, yung kanilang difference same lang din in every replicate. So that's proportional bias. Okay. For constant bias naman, the reported values are higher than the expected values by a constant amount at all concentration. Exists when there is no constant difference between the comparative method and there is constant difference and the test method regardless of the concentration. Ayan. Paano natin nakita ang constant bias? Okay. We have 5 patients. Sabihin natin may 5 patients. Yung 5 patients na to, they are requested for a fasting blood sugar by their attending physician. And then, since merong constant bias, example, niran mo si patient to 1. Okay. Niran mo si patient to 1 sa test method mo, and then niran mo si patient 1 sa comparative method. Ayan. Ang nabasa mo sa test method is 90 milligrams per DL. Ang nabasa mo sa comparative method is 100. That's patient 1. Patient 2, ang nabasa mo sa test method is 90 ulit. Ang nabasa mo naman sa comparative method or sa reference method is 110. Okay. Patient 3, ang nabasa mo sa test method is 90 ulit. Ang nabasa mo sa comparative method or sa reference method is 95. Patient 4, ang nabasa mo sa test method is 90 ulit. Ang nabasa mo sa reference method or sa comparative method is 115. Next, patient 5, ang nabasa mo sa test method is 90 ulit. Ang nabasa mo sa reference method is 120. Based on those data, there is a pattern. Ibig sabihin nun, yung test method na ginagamit mo compared to the reference method or sa comparative method, meron silang difference. And then the values obtained from the test method is constant regardless of the actual concentration. Gets nyo ba yung pagka-example ko doon? 90 lahat, yung 5. That's constant 90. Pero yung kanilang actual value based on the reference method is nagde-deviate. Okay. Kasi as a medtech also, kung nag-run ako ng 3 patient tapos yung 3 patient is pare-parehas yung resulta, magtataka ka talaga. Constant bias yung ganun. Kasi parang napaka-imposible naman na 3 patient, pare-parehas sila ng resulta. And the results are numerical pa. Ibig sabihin ng numerical. Value. Like pwede namang yung isa 90, yung isa 92, yung isa 93. Bakit 19 tatlong pare-pareho? So you need to investigate what is the problem in the test process. Ganyan. Unlike for the qualitative results like HIV na 3 sunod-sunod na positive, okay lang yun. Kasi nga positive sila talaga. But if you're going to determine a quantitative result like 90, 90, 90, 90, ganyan, medyo magtataka ka na din. Okay? That's a example of a constant bias. Regardless of the concentration, iisa lang yung nababasa ng machine mo. Iisa lang yung na-interpret ng machine, iisa lang yung nababasa niya. Regardless of the concentration. Okay? Ganun yung ibig niyang sabihin. Clerical error. Okay. Clerical error, ito yung error done by the staff medtech or the intern or the medtech intern. Okay? Ito yung mga clerical error. Okay. Description. The highest frequency of clerical error occurs with the use of handwritten labels and request forms. Okay. So sa clerical error sa laboratory is staff medtech or medtech intern. But clerical errors also happen by the nurses. Okay. Kasi nga in my experience kasi all request forms in the laboratory are written. Written talaga. Parang ilan lang yung encoded na lab request. Lahat written. Yung nabasa ko written. And kapag written yung request form, ano yung mga common mistakes? Ano yung mga common mistakes? Yung pag-transcribe ng patient info, wrong spelling, kapag encoding, ay kapag sinusulat, ano yung mga nakakalimutan ilagay ng mga nurses? Patient diagnosis, nakakalimutan na lang ilagay. Next one, kapag sa mga pag-check ng mga test request, kasi yung itsura kasi ng test request, andoon lahat ng test sa lahat ng section. And upon ordering ng test request, the nurse or the physician will check only the boxes. Sometimes, magtataka ka na bakit magtataka ka minsan na parang electrolyte panel yung parang electrolyte yung i-request ng physician pero walang potassium na na-check, ganyan. Yun pala, nakalimutan lang i-check ng nurse, ganyan. Kasi nga, kung electrolyte, sodium, potassium, parang lagi siyang magkasama. Commonly. Routinely, laging magkasama ang sodium and potassium because they are counter ions. Kapag mataas yung isa, mababa yung isa. Kapag mababa yung isa, mataas yung isa. That's counter ion sa electrolytes. Kaya minsan, kapag naka-receive kayo ng request and then sodium lang yung nakalagay, minsan tumatawag kami sa nurse ward, like we're going, kina-counter check, like, ma'am, si patient De La Cruz po ba, sodium lang po ba talaga yung request niya? Tapos tatanungin ni nurse kay doctor, ay, pakicheck na din po pala yung potassium, nakalimutan lang, ganyan. Also for lipid, for enzyme panels, ganyan. AST, SGPT, AST, nakakalimutan lang i-check minsan yung iba, ganyan. So that's a request form, okay? Okay, so ganyan. Clerical error yung mga yon. Mga wrong spelling, wrong yung birthday, wrong yung naisulat wrong yung birthday na naisulat sa request, pero yung record niya sa hospital sa library information system magkaiba. So that's again part of the clerical error na sinulat. So i-check niyo 'yon. Also for the birthday, ganyan. Ayun pala, birthday pala. Also for the age pala, magkakaiba minsan. Kaya you need to recheck, ganyan. Handwritten labels. Handwritten labels, okay. So, yung labeling kasi sa laboratory, parang dalawang patong na yun. Dalawang patong. Yung una, if you're going to label a blood specimen, di ba sinusulat doon? What are the three identifiers of labeling? At least 3. Kasi madaming isusulat sa tube eh. Pero at least 3, pwede na. Okay? The name of the patient, the birthday of the patient, and then the age of the patient. Kahit yung tatlo lang na yun, okay na. Okay? Yun yung identifier. Pero yung according to protocol kasi, hindi lang yun. Okay? The name, the age, the birthday, the gender, the date to day, the date of the request, the sign, yung sign ng extractor doon sa may tube also. So masyadong madami. Basta meron yung tatlong identifier and then the date of collection. Yun yung importante. Okay? Date of collection, tapos yung tatlong identifier. That's very important. Okay? Kasi guys, sa may request form, yung mag-extract, Sasayanan niya naman doon yung, for example, extracted by Juan de la Cruz. Bakit napaka-importante lagyan ng date of collection yung isang specimen? Kasi aside from the three identifiers, kailangan nilagyan ng date of collection para alam kung ano para alam kung anong date kinuhanan kasi lalo na kapag inpatient yung kapag inpatient yung patient, kapag inpatient, ibig sabihin no, naka-admit yung patient sa hospital, the doctor will request complete blood count almost every day, as in every day. Nagpapa-CBC yung patient to update the treatment. So, every day merong CBC, every day merong FBS, ganyan. Kaya minsan, kung intern na kayo, parang nafa-familiarize na kayo sa mga patient nyo na parang araw-araw nyo na-encounter si patient na ganito, ganyan. Kasi every day nagpapa-CBC. Okay? Ayun, kaya kailangan merong date of collection. Kung wala, kasi kung walang nakalagay na date of collection, tapos dalawa yung specimen niya sa bench ng HEMA or CC, medyo magtataka ka na. Ayan. Kaya dapat merong label, ganyan. And then usually naman, yung mga kinokollect na specimen within that day, tawag dito, within that day, parang fina-file siya. Fina-file yung mga specimen extracted within that day, tapos nililabel doon. Okay. Okay, ano lang. Gusto ko lang i-share na during my internship, di ba kasasagan nun dati ng measles outbreak, yung CBC ng San Lazaro dati, umaabot siya ng 1,000 isang araw. Sobrang dami talaga. Sobrang dami ng CBC, umabot ng 1,000 CBC per day. Ganon kadami ng specimen. Grabe. 500, 800 to 1,000, 500 to 800, ganon. Isang araw lang yon sa dami ng pasyente. Tapos, and after that kasi, everyday yon kasi lahat ng measles patient admitted sa hospital. So, everyday, meron silang CBC. So, hanggang uulit-ulit. And, later na lang yung delta checking. Okay. So, for the pre-analytical errors, they are self-explanatory naman. Lahat ng variables included in the pre-analytical phase, ito yung mga possible errors na may encounter. Okay? Parang ito lang yung counterpart ng pre-analytical phase variables. Ayan. Improper patient ID, mislabeling, incorrect order of draw. For example, inuna mo lang mag-EDTA bago ka mag-sodium citrate, hindi na maganda yun. Incorrect patient ID, improper patient ID, wrong specimen container. For example, yung test request is CBC, tapos nag-collect ka sa blue top, hindi maganda. Incorrect anticoagulant to blood ratio. Yan, for example, yung specimen mo is EDTA lang, pinuno mo na punong-puno na yung EDTA, hindi na pwede. The anticoagulant, hindi na siya efficient to anticoagulate the blood. So, anong pwede mangyari kapag punong-puno yung EDTA? Pwede mag-clot yun or magkakaroon ng microclots. Kapag nagkaroon ng microclots, bababa ang platelet count, tataas ang white blood cell count, ganyan. Improper mixing of sample and additives. For example, yung EDTA, nextrakan mo, dahil puyat ka na sa night duty, hindi mo na na-invert. Ganun mo na lang. Pagdating mo sa lab, buo na. Recollect ulit. Ganyan. Incorrect specimen preservation. Same lang din. Same lang din sa tubes. Ganun lang din. For example, yung request ng patient is coagulation studies, PT-PTT. Kinolect mo siya sa EDTA. Yun pwede. Incorrect use of tubes for blood collection. Ayan. For example, for blood culture, hindi mo siya na-collect sa ACD or sa clear top or sa culture bottle. Mangyayari, pwedeng hindi ka maka-culture or madami kang mako-culture kasi nga hindi control yung laman ng tube na yon. Ganyan. Mishandled specimen. Kapag mishandled yung specimen, what are the possibilities na pwede mangyari? Pwede magkaroon ng hemolysis, ganyan. Pwede hemolysis, underfilled tubes, ganyan. Yan yung mga nangyayari. Missed or incorrectly interpreted laboratory requests. Naiiwasan na din yan dahil sa automation. Kasi nasabi ko sa inyo, ay, lab request pala. Missed or incorrectly interpreted lab requests. Ayan. Minsan kasi guys, as medtechs kasi, hindi lang tayo focus doon sa resulta or sa testing process. We are medical detectives. So the results must be correlated well with the patient. And for example, okay, si Juan de la Cruz, admitted patient, meron siyang dengue. Nakalagay sa kanyang patient diagnosis is dengue fever. Si doctor or si attending physician nag-request siya ng NS1 antigen. Nag-request siya ng complete blood count. Nag-request siya ng liver panel. Yeah, yung request niya sa isang patient. Since you are a intern or a staff in hematology, ang gagawin mo dyan, kapag nag-run ka ng CBC, tapos nakita mo yung platelet niya is 10 lang, or nakita mo yung platelet niya is 10 lang, yung mga cell counts niya normal naman, pero yung kanyang platelet is nasa 10. Usually nasa 150 to 1, kasi yung normal range ng platelet is 150 to 450, tapos nasa 10 lang yung kanyang platelet count. Magtataka ka, bakit ang baba ng ano niya? Bakit ang baba ng platelet niya? Tapos tinignan mo yung request niya. Nakalagay, nakita mo doon, dengue fever. Ay, okay, may dengue pala yung patient. So, pwede natin i-release itong result na to. Sa sign na yan ng medtech, i-release niya na. Okay. Isa naman, si patient Juan de la Cruz again, from other hospital. Okay, meron siyang physiologic condition. For example, dehydrated, ganyan. Parang nagkaroon siya ng fainting, ganyan. Tapos, tinest mo yung blood niya for hema. And then, nirun mo yung kanyang CBC, medyo mababa yung kanyang RBC, mataas ang kanyang white cell, sobrang baba ng kanyang platelet, nasa 50 ganyan. Magtataka ka. Bakit ang baba ng platelet niya? Tapos tinignan mo yung kanyang patient diagnosis, hindi naman siya related sa thrombopoiesis, ganyan. So you're going to investigate. Anong gagawin? Parang gagawa ka ng smear. I-smear mo yung blood niya. Titignan mo sa microscope. Pagtingin mo sa microscope, clotted pala si specimen. Clotted yung specimen, ibig sabihin the platelets are not counted kasi nagka-clump na sila. Since madaming nag-clump na platelet, that is counted as a white blood cell count in flow cytometry sa Sysmex or sa hematology analyzer. Ayan. So you are investigating. Para i-correlate mo lahat. For example, merong purpura, mababa yung platelet niya, okay lang. Ganyan. Kapag masyadong mataas ang monocyte, magtataka ka. Kasi parang wala namang infection yung patient, ganyan. Titignan mo sa smear. Ganyan. So hindi lang tayo basta release ng resulta. We need to investigate. Dapat yung prognosis ng physician at a point, dapat you are agreeing. Kasi yung mga physician natin, magagaling na sila eh. They actually know kung ano yung sakit nila. Parang gusto lang nila ng clinical evidence para ma-validate yung kanilang prognosis. Kasi based on physical evaluation, based on their history, based on their symptoms and signs, parang sure na sila. Parang, di ba, sabi ko sa inyo kanina, 70% of medical decision happen after a lab request. A lab result. Okay? So parang yung 30% na yon, parang sa physician siya. So at yung 30% na yon, malaki pa din yung chance na tama yung prognosis ng physician. For example, yung prognosis ni physician is dengue kasi nga madaming pantal, ganyan, tapos nagbe-bleed siya, ganyan, kasi mababa yung platelet. Kapag sinabc yun, dapat mabawi yung platelet niya. Ganun lang. Correlation. That's why the relationship of all the healthcare worker in a healthcare setting is symbiotic. Ganyan. Dapat nag-agree lahat. From medtech, to nurses, to doctors. Symbiotic yan. Okay? Walang superior over the other because hindi mag-run ang healthcare system any without medtechs ganyan. Kaya dapat mahalin niya ang course nyo. Yun lang. Okay? Analytical error. When we say analytical error naman, instrument not calibrated correctly, improper incubation or timing, specimen mix up and carry over. Saan nangyayari ang carry over? Nangyayari ang carry over sa improper order of draw. Okay. For example, tawag dito? For example, kinolek mo muna si EDTA, tapos nag-SST ka or nag-serum separator. Pwedeng hindi mag-clot yun, yung serum separator, kasi nga the anticoagulant from the other tube is carried over to the other tube next. Lalo na kapag ginagamit ang evacuated tube system, yung two-way needle. Okay? Hindi yun, magkakaroon mataas kasi yung chance ng carry over kapag improper yung order. Sa midterms ninyo, yung tawag dito, March 7, yung mga second cycle, if I'm mistaken. Okay, yung inyong first practicals is order of draw. Yan, ito yung mangyayari. Incorrect volume of specimen and reagent, instrument precision problem, interfering substances present. Ayan. Saan nyo na-encounter? Nalikas natin yan noon sa biochem. For example, interfering vitamin C to urine parameters like yung bibilang, blood, bilirubin, leukocyte, nitrite, and glucose. Kapag masyadong mataas ang vitamin C, kapag above 25 milligrams or micrograms per ml, pwedeng mag-interfere. Magiging negative yung 5 parameter na yon. So that's interfering in substances or present. Ayan. Oversight of instrument flags. Nakikita ito sa interface ng machine, yung instrument flag. Nagpa-flag kasi yung machine kapag parang kapag yung result is masyadong mataas or masyadong mababa. If the result is on the panic value, ganyan. In actually CC2, in your CC2, sa electrolytes, doon nyo ma-encounter yung mga flags and panic values. Sabihin nun, kapag masyadong mataas or masyadong mababang potassium, pwedeng mamatay yung patient. Ganyan. Yung potassium, kapag masyadong mataas o masyadong mababa, pwedeng mamatay yung patient. Ano? Kaya tinatawag siyang panic values kasi that value can cause critically sa patient. Ganyan. Out of control QC result. Kapag out of control, sabihin nun, hindi reliable yung resulta. Wrong acid perform. Okay, wrong acid perform. Ano yan? Part siya lang clerical error. Kasi parang puyat na yung intern. Ang nakalagay sa resulta niya ang nakalagay sa request niya is NS1 antigen for dengue. Tapos yung pinreform niya is measles IgG IgM, ganyan. So medyo hindi na nagaano, ganyan. So you need to read the request properly, ulit-ulit yung basahin, and make sure na tama yung test before you're going to do it. Okay, ganyan. Meron pala akong share dito. So may incorrect anticoagulant to blood ratio. Nasabi ko sa inyo kanina, di ba, na if a nurse is working in a tertiary government hospital, they need a certification in phlebotomy para sila nang mag-collect in cases of stat specimen or results must be carried out within 1 hour upon request. Yeah. So sila nang kumokollect ng sample and then sila na din yung nagbababa ng request together with the specimen. So tatanggapin na lang medtech, i-run na agad, release agad yung resulta, ganon. I have one time ah, nakatanggap kami ng stat specimen from the P ward. Tapos, yung EDTA niya, punong-puno. Hindi na nga ma-close yung tube kasi punong-puno na. So, parang nagtingin na kami ng co-intern ko, tapos medyo tumatawa kami ng konti kasi bakit parang punong-puno, ganyan. Tapos ang ginawa namin, ah, "Sir, pare-collect na lang po ng specimen kasi po punong-puno," ganyan. "Hanggang sa may line lang po, hanggang sa may fill line niyo lang po punuin," ganyan. So yung ginawa namin ng intern ko, binalik namin yung specimen and yung request. Tapos after 30 seconds, bumalik na yung nurse, sabi ko. Sabi namin, "Ba't ang bilis?" Tapos nasa fill line naman, pero 30 seconds lang. Sa fill line naman. Tapos, tinanong namin, sir, bakit ang bilis niyo po? Tapos sabi ng nurse, tinapon ko po yung kalahati. Tinapon niya daw yung kalahati para mapunta sa fill line. Hindi naman ganun yun, di ba? So sino may kasalanan doon kapag ganun yung case? Kasalanan ng medtech, kasalanan ng laboratory. Yun. Kasi kung ganun yung pinasang specimen sa laboratory, dapat kino-confiscate na yun. Hindi na binabalik. Kaya ipapaano yun, ipapa-recollect yun. Hindi yun pwede. Nagalit na nga yung staff namin dati kasi may mga certification naman sila for phlebotomy, bakit hindi nila magawa lang maayos yung blood collection. Isa pa, yung nurse aid namin, yung lab aid namin, since sila yung nagko-collect ng specimen, yung mga laboratory aids, merong request, stat specimen again from the nurse station. Ano siya? Coagulation studies, color blue top tube. Ayan. So napansin namin, proper naman okay naman yung feel ng specimen, pero clotted. Tapos sabi ko sa nurse, sa lab aid namin, "Sir, clotted naman, sir," sabi ko. "Sir, hindi to pwede," sabi ko. Tapos sabi niya, "Hindi, okay yan," sabi niya. "Okay lang yan, isentry mo lang yan," sabi niya. Sir, hindi pwede to, ganyan. Kasi clotted nga. By the way, yung mga lab aids sa laboratory, majority, hindi sila RMP. Mga ano lang sila, kinuha lang sila para tumulong. Sila yung mga taga-hugas ng tube, taga-walis, taga-receive, ganyan. And we are lucky enough na sa San Lazaro Hospital, may mga laboratory aids, may mga katulong kami doon. Kasi most of the affiliated hospitals of SMU, like Cagayan Valley Medical Center, JJI, Bulacan Medical Center, wala silang mga lab aid. Ibig sabihin nun, mga intern yung pinaghugas ng tube, mga intern yung pinag-roll ng cotton, mga interns yung pinag-o-ovenan sila yung mga nag-o-oven sa tubes para ma-dry, ganyan. We don't do that. Hindi ko na-encounter yung gano'n. Tsaka hindi yung pwede. Bakit? Hindi naman tayo slave. We're interns, right? We're there to learn. Kaya we're lucky enough na madaming lab aid sa San Lazaro. Kaya push nyo mag-San Lazaro. Para hindi naman siya nang mahirapan. Kasi stress na nga sa duty, guguwasan pa kayo ng tubes, ganyan. Though it's a part of the process na maghugas ng tube, mag-roll ng cotton, pero interns must learn, di ba? From everything. Madaming stress na, puyat-puyat na, wala nang sahod ng interns, di ba? Parang tayong slaves ng intern, ganyan. Medyo slave yung feeling, ganyan. Pero it's part of the process naman. Okay? So, yan. Post-analytical error. So, lahat din ng variables from the post-analytical phase, they are ito lang yung mga errors na possible na ma-encounter sa post-analytical phase. For internship, yes, student ang mamimili ng hospital, but in some hospitals there are only certain slots For example, for Baguio General Hospital, for each school, parang 10 lang yung pwedeng pumasok. So parang paunahan, ganyan. Paunahan tumapos ng thesis, paunahan tumapos ng requirements, para pauna ka sa slot, ganyan. For Cagayan Valley Medical Center, parang hindi naman masyadong stricto doon. For Bulacan Medical Center, it requires qualifying exam or entrance exam. Hindi naman siya yung ano, parang exam lang, pero tatanggapin pa rin lahat, ganyan. Also for in Nueva Ecija, JGI, ganyan. Accept lang sila ng accept. I took ITRC. Ang tawag yun? Ilocos Training, ITRMC. Ilocos Training and Medical Center. Okay lang din sila, nag-accept lang din sila. For San Lazaro, ito yung medyo choosy. Medyo choosy sila. They do not, sa per school, hindi sila yung per slot per school. They are conducting qualifying exam and interview sa San Lazaro Hospital para ma-qualify ka as their intern. Ganyan. Ganon yung San Lazaro Hospital. Though mahirap pumasok sa San Lazaro Hospital, pero sobrang worth it. Lahat ng knowledge, lahat ng skill, as in sobrang pasok na pasok talaga sa clinical talaga pag San Lazaro. Since San Lazaro Hospital is the only Metro Manila base affiliated hospital of SMU. As in talaga, ang daming patient doon. As in bugbog talaga lahat ng cases, maka-encounter nyo lahat talaga. Basta ganon. For San Lazaro, ganyan. Okay, so in our batch, sa batch namin, yung mga nag-qualifying exam, we are 300. So kasama na lahat dyan, like SMU, CEU Manila, FEU Manila, FEU NRMF, Chinese General Hospital, tawag doon, Chinese Gen, Misamis University, ano tawag dito? St. Cabrini, LPU St. Cabrini of Batangas, LPU Laguna, Cavite State University, mga ganon. Basta mga Metro Manila schools, yung may mga matatalinong UERM, basta lahat ng mga Metro Manila schools, ganyan. So at first, nakaka-intimidate kasi. Siyempre mga Metro Manila schools, sila ganyan. Tapos parang konti lang yung mga province like Misamis and SMU, mga ganyan. Tapos, during the qualifying exam, PowerPoint, and then sa amphitheater, then you're going to answer 100 items. 100 items na multiple choices items. Multiple choices. And then UERM, sila yung pinakamadaming population na natanggap sa San Lazaro. Hindi ko alam kung anong secret nila. Or talagang matatayin talaga kasi lahat ng nag-intern sa San Lazaro, mga cum laude ng Metro Manila School. So andun yung mga cum laude ng UERM, ng FEU, andun yung mga PAMIT scholar, mga ganun, mga safeguard scholar, doon lang nag-i-intern sa San Lazaro Hospital. Ganyan. So sa batch namin, 3 kami natanggap. Si Giles, yung top notcher. Si Giles, ako, tapos yung isa, si Charibel Bacani. Yung co-intern na classmate ko din. 3 na kami tanggap. 14 kaming nag-exam. 14 Marian senior students yung nag-apply for San Lazaro Hospital. Kaming 3 lang yung pumasa sa written exam, and then nakuha kaming lahat sa interview. Pero si Giles kasi, hindi siya tumuloy sa San Lazaro. Hindi ko alam kung anong reason, kasi hindi siya tumuloy sa San Lazaro. Sa UERM pala, 12 silang natanggap. 12. As in 12 interns of UERM. Sobrang dami nilang natanggap sa San Lazaro. Grabe. Kapag 10, madami na yun, sobrang dami na. Kasi yung ibang school nga, for example, yung IRA, isa lang yung tanggap doon out of 10, ganyan. For FEU NRMF, 15 silang nag-exam, 5 lang yung natanggap, mga ganon cases. Pero worth it naman. Worth it. Okay, so para magyan ka ng motivation, sa Natural Hospital kasi, since madaming section na wala sa routine na wala sa routine na lab setting, interns of San Lazaro Hospital are immersed also in seminars weekly. May mga seminar. So kasama mong magkaklase yung mga taga FEU, mga taga CEU, ganyan, mga taga Chinese Gen. Sama-sama kayo sa amphitheater. And then the staff will discuss, like they will discuss nucleic acid test. They will discuss HIV, ganyan. Mga ganon. And they will discuss everything under the section. Mga ganon. And then, tawag ito, sobrang ganda ng mga seminar kasi yung mga nagkakandak ng mga proficiency testing or yung certification for HIV, proficiency testing, sila din yung nag-discuss sa inyo about HIV, like super high profile, high caliber stuff, mga medtech 4 ng SACL, mga ganun yung mga nag-discuss sa inyo. So sobrang nakaka-amaze talaga. They will discuss you all, like everything. I-rotate kayo sa mga laboratory. They will they will demonstrate you how to do the Western blot for HIV, ganyan. So it's a very good experience talaga. Kasi sulit naman. Sulit naman. Ayan. And by the way pala, during my rotation in SACL, nagkataon na merong proficiency testing on HIV counseling. Ganyan, sa mga mag-a-apply. Parang ano siya, parang drug testing analyst. Kasi hindi lahat ng medtech pwedeng maging counselor or pwedeng mag-test ng HIV. Yung mga medtech lang na yon, they have the certificate or training na ginagawa sa SACL, 18,000 pesos para mabigyan kayo ng certificate or para ma-train kayo on how to give counseling sa patient na may HIV, on how to test properly the HIV, ganyan. Si Ma'am Sheila, HIV siya, HIV proficient, si Ma'am Sheila. Ma'am Sheila is a HIV proficient registered medical technologist. Ayan. Ano siya, proficient siya sa HIV. Nag-training siya sa San Lazaro, si Ma'am Sheila. Okay, ano pa ba? Yun lang. Yun lang muna. Masyado nang matismis dito. Kaya if I were you guys, galingan ninyo sa mga major exams and then, kasi kapag maganda yung grade ninyo before internship, mas madami kayong choices. Kasi yung kinukuha lang sa San Lazaro, yung mga estudyante na walang grades sa major subjects below 82. So dapat 83 pataas yung grade nyo sa lahat ng major subject nyo bago kayo makuha. And we are only 14 in our batch na merong ganung profile. Kaya galingan ninyo para madaming Marians na maging San Lazaro interns later. Kasi maganda talaga ito. Yun lang. Okay, resume tayo. Ito, verbal reporting of result. Ito yung sinasabi ko sa inyo kanina. Bawal sabihin, bawal itawag. You need to give the result in prints. Hindi pwede yung tinatawag kasi may mga makulit minsan na yung mga nurses kasi pinapagalitan sila ng mga physician, bakit daw wala pa yung resulta? Ganyan. Si physician, medyo high blood na siya, parang binubunton niya yung kanyang fingers, kay nurse, bakit wala pa yung resulta, ganyan-ganyan. So si nurse naman na natataranta na, matawag na sa lab, and then sinasabi niya, ano po yung resulta ni yung ganito ni patient ganito. As a medtech, as an intern, hindi po ipapadala na lang po namin dyan sa ward or pwede pong kunin ng nurse aid yung resulta dito sa laboratory kasi mamayang alas 2 pa po, alas 4 pa po yung releasing ng resulta. Ganyan. By the way guys, warding and releasing are scheduled. For example, for warding of specimen, it is only be done at 4 a.m., 4 a.m., like 2 p.m., like 12 a.m. May mga schedule. Kasi parang iniipon yung request. And then kapag pagpatak ng alas 4 ng madaling araw, that's the morning peak warding. Lahat ng intern magigising na at magsisiwardan na sa lahat ng wards ng hospital. Okay. And instrument LIS compatibility. Okay. All instruments must be compatible with the library information system of the laboratory. Yan. Kasi nga yung resulta na nakuha ni machine or ni instrument, dediretso na siyang pupunta sa LIS or sa library information system. So basically, so lahat kasi ng section may mga sariling computer yan. So the computer of blood banking, pwede mo makita yung result ni patient 1 de la Cruz sa hematology. Ganun. So they are interconnected. It is a network. Kaya makita lahat. Okay? Lahat ng record, results, ganyan. Confusion about reference ranges. Confusion about reference ranges. Ayan. Ano na naman to, hindi naman to masyadong naki-question. Pero ano lang ito kapag sinulat manually yung reference range, kapag hindi maganda yung pagsulat, wrong yung unit. For example, imbis na isulat mong 90 milligrams per deciliter per glucose, nasulat mong 90 millimoles per liter. Questionable siya kasi sobrang taas yun, di ba? So dapat, 90 to 110 yung reference range, pero wrong yung unit, nakalagay siya sa SI, dapat di yun pwede kasi masyadong mataas. So basically, if you were the physician who will interpret the result, it's basically parang masyado namang OA o masyadong mataas. So, confuse yung magbabasa ng request, ng result. Confused na yun. Ganyan. Okay, reference materials. Ano na to? It is discussed during our overview. They are reference materials, they are reference solution. They are used for calibration, they are used for test validation, ganyan. Calibrators, formerly known as standards. Ayan. Di ba sabi ko sa inyo dati, standards and solutions. Because calibrators are formerly known as standards. Medyo confusing kasi kapag sinabing standard. Saan siya ginagamit? Pero when you say calibrator or calibrator solutions, malalaman mo. Kasi these types of solutions are used to calibrate instruments. Kasi nga they are calibrators, di ba? Kasi ang mga calibrators or standards, ito yung clear yung matrix ng solution. And then if feed mo sa machine, kapag tama yung basa ng machine, gumagana pa yung machine, calibrated pa. Pero kapag hindi na-read ng mabuti or masyadong malayo yung value ng na-read ng machine compared to the stated value by the manufacturer, ang mangyayari doon, hindi na calibrated. So you need to calibrate it. Ganyan. You need to, you need to maintain. The instruments need a maintenance from an engineer. Okay? Kasi guys, engineer yung mga parang kumakalikot sa mga machine. Yeah. For example, si machine for CM, for urinalysis, parang hindi siya maka-aspirate ng urine. So si medtech, since hindi niya alam yung troubleshoot, kasi parang hardware yung issue, hindi siya software. Tawagan niya yung manufacturer, tawagan niya yung engineer. Sir, pwede po ba kayong pa-appointment po ng ganito, ganyan, kasi para maayos yung machine. There are two types of standard or calibrator. Primary and secondary. Yung si primary, they are chemically pure, can be weighed or measured directly. For the secondary naman, ito yung less expensive and in comparison to the primary standard, mas magandang gamitin si primary standard. It usually contains one analyte. Yung sinasabi ko sa inyo noon. Unlike sa mga solutions, ay sa controls na it represents a body fluid and body fluids are solutions and they contain many analytes. Ito yung kanyang counterpart, si calibrator. Kasi isang analyte na yung kanyang mini-measure or yung present doon sa interface. Control specimens, ayan, are tested with the patient sample and serve the purpose of to monitor the precision of the test method. Okay. What are the qualifications para maging maganda yung ating control solution? Okay. It should behave like the real specimen. Should available in sufficient quantity to last a minimum of 1 year. Should be stable over a longer period of 1 year. Should be available in convenient vial volumes. So dapat laging mayroong stock na control solution sa laboratory. Okay. Laging merong stock yan. Dapat hindi nauubusan ng control solution. Bakit ang sabi dito, it should be available in convenient vial volumes. Bakit hindi pwedeng yung control solution is litro-litro? For example, nakalitrong serum, nakalitrong whole blood for CBC ganyan. Hindi yun practical. At mataas yung chance na mag-deteriorate agad. Kasi once kasi na binuksan mo yung malaking container, meron ng introduction ng air doon. So, ito magkakaroon ng degradation, kakaroon ng any other changes or deterioration if that solution is exposed to air. Kaya hindi na mga nagamitin yan kung gano'n. That's why, inconvenient vial volumes, you're just parang nakakontrol mo kung gaano kadami yung gagamitin mo lang for this type of shift, ganyan. Kasi kung maubos yung isang vial, kuha ka ulit ng isang vial. Yan. Para yung hindi minsan ang bukas. Ganun. Okay. Should include clinically normal, high and low abnormal ranges. Ito, yung mga positive values natin. Okay? Dapat merong high normal, high abnormal, low abnormal, and the normal or the normal range. Okay? Ganyan yung mga controls natin. Some analytes, meron silang mga negatives, ganyan. Okay, para lang ma-determine, but routinely and commonly, ito yung mga levels of control na nandito sa mga specimen, sa mga control solutions like normal control, high abnormal control, and low abnormal control. Ano bang ibig sabihin yan? Kapag finid mo si normal control sa machine, dapat ang mababasa niya within the normal range. Kapag finid mo si high abnormal range, dapat ang mababasa ng machine mo is above the upper limit or the upper limit of the normal. Ganon. That's ba? And same lang din with the low abnormal range. Should be preferably lyophilized, require constitution before use. Ayan. Should be preferably lyophilized. Ayan. Since this is a control specimen, kapag binibili ito sa manufacturer, naka-liquid form na siya. As in naka-liquid form na din. But preferably, it is lyophilized. Ang ibig sabihin ng lyophilized, dapat powdered form. Dapat in powdered form yung control solution. And it requires reconstitution before use. You must reconstitute the solution. You must reconstitute the lyophilized material with type 1 water or a water with a higher purity standard, kanya, para uniform yung kanyang matrix. Ayan. Paano tayo gumagawa ng controlled sera? There are two: commercial pooled control sera and commercial controlled sera. Ito yung mga binibitin na yung ginagawa commonly, yung commercial controlled sera. Okay? Ito yung binibili sa manufacturer, yung mahal siya. Kaya nga sa Pilipinas, ang pag-run ng control at least once a day or at least once per shift kasi mahal talaga ang mga control sera. Okay? Pero sa ibang bansa, syempre, they do the control every procedure, ganyan. So, mahal itong commercial control sera, but traditionally, we use the pooled control sera. Paano ginagawa itong pooled control sera? From the words of pooled. Ibig sabihin nun, if you're going to make a normal control sera from pooled specimen, lahat ng pasyente mong normal value, kukunin mo lahat ng kanilang mga serum and then yun yung ipopool mo sa isang container, kaya ang pool. Okay? So laboratories prepare their own control wherein they should collect a large pool sufficient to last 1 year. Okay, also 1 year pa din yung kanilang stability, ganyan. What are the shortcomings of pooled control sera? Deterioration, contamination, loss of potency due to deterioration. And ano yung pinaka-notable na drawback ng pooled control sera? Exposure to pathogenic agent. Since ipopool mo yan, open system, ipopool mo siya sa isang container. And then, hindi mo naman alam. Kasi kahit sabihin mong normal yung kanyang glucose, paano kung merong STD yung isang patient? Paano kung merong, paano kung merong is performing ba sila yung specimen, ganyan. Nakatakot, di ba? Kaya dapat, hindi na ito recommended na ginagawa kasi madami siyang drawbacks or fallbacks. Okay? Commercial control serum, either prepared from human serum or from bovine-based products. Okay. Ito yung, ano yung, pag sinabing bovine-based products, cow, mga cow serum, ganyan. Those are bovine. Okay, mga cow serum, calf serum, ganyan. And also human serum as well, but the human serum used here are purified. They are purified na. So medyo safe na siyang gamitin. Okay. Notes to remember for QC prep. QC material should resemble human sample and be available for a minimum of 1 year. Human control materials are preferred, but because of limited sources and biohazard considerations, bovine control materials are used. Ayan. So, mas safe lang gumamit ng bovine today sa mga control, sa mga commercialized control sera. Okay. Okay. But ilang controls yung ginagamit? Dalawa lang. Dalawa yung ginagamit for routine QC. Kanina kasi, yung high normal and high abnormal, low abnormal. Okay? Minsan ginagamit sila, pero minsan hindi na. Minsan dalawa lang, like normal and high, or normal or to low. Depende yan sa analyte na gagamitin. Later we will discuss that later. Okay? Parang 'di ba, last time nasabi ko sa overview na dalawa yung common na ginagawa, di ba? Dalawa yung common na ginagamit, except yung tatlong test na tri-levels like ABG, enzyme, and hormone yata. Yung tatlo, yung tri-level. Pero usually 2 levels lang yung ginagamit, depende sa analyte. Like, pwedeng yung control is low abnormal and high abnormal, ganyan. Or normal and high normal, ganun yung ginagamit. Ganun yung kinokontrol minsan. Okay? Pero ano siya parang it is preferred to have the 3 levels of control in every analyte kasi mas maganda siya, hindi lang dalawa. Pero some research and study suggest that 2 levels of control in in most of the analytes are sufficient enough. Okay na din yung 2 levels of control. Okay? Yan. So what is the drawback of bovine-based QC material? It is not a choice for immunochemistry, dye binding, and certain bilirubin assay. Immunochem and dye binding and certain bilirubin assay. Sa serology ito. Okay? Okay. For immunochemistry kasi, hindi pwedeng gumamit ng mga ganitong materials because some materials have inhibitors in them. Inhibitor. For example, in bacteriology, in media preparation, bakit hindi pwedeng gumamit ng human whole blood in preparing chocolate agar plate and blood agar plate? Ganyan. Bakit ang recommended na gamitin is rabbit whole blood? Kasi guys, ang human whole blood may mga inhibitor, may mga antibiotics. Kapag may mga inhibitor, may mga antibiotics, may mga viable cells, and then kapag nag-culture ka sa blood agar plate na merong merong human whole blood, yung composition ng human whole blood, it can interfere with the growth of clinical isolates. Ganun. Mga ganong interference. May mga inhibitor, may mga antibiotics, may mga cells, mga ganyan, na hindi pwedeng present para magkaroon kayo ng growth sa blood agar plate. Ganun. Those are inhibitor. Same as here. Hindi ka pwedeng gumamit ng bovine-based QC solutions kasi they also have inhibitors for immunochem. Since the process is immunology in those. Pag may mga inhibitor yan, hindi magkakaroon ng reaction. It's as easy as that. Okay? Ganun lang. Okay. Meron pa tayong isa. Mabilis na lang yung 30 minutes na lang. Break lang ulit. Masakit na lamunan ko. For quality management part 2. Okay. So ito yung nasa activity 4. 4 ba yun? 5 pala. Activity 5. Okay. So the part 2 is composed primarily of statistics. Okay. So there are two types of statistics, the descriptive and inferential. When we say inferential, you are comparing variables when you say inferential. And descriptive naman, parang description lang, ganyan. You're just going to determine what is presented in a single set of data, ganyan. So, meron naman na kayong mga, siguro nabugbog kayo na sa senior high ng mga research, ganyan. So, alam niyo na yung mga ANOVA, mga t-test, f-test, correlation, ganyan, mga chi-square test, mga ganyan. They are part of the inferential statistics. Okay? When we say central tendency naman, the median mode, measures of dispersion or spread. This type of descriptive statistics determine how well a data is close to each other. So basically they are they determine the precision, ganyan. Okay. Measures of shape dito sa later. Okay. So yeah, under inferential, we have parametric and let's wait lang. Okay. Okay. So this descriptive naman tayo. Measures of center, mean. Ano ba yung other term ng mean? Average. So pag-alin mo lang yung values, then divided by the number of values. So that's the mean. When we say median naman, this is the 50th percentile or the 50% of values. For mode, this is the frequency kung gaano ka-frequent magpakita yung isang data. So parang unimodal, mga bimodal, trimodal, mga ganyan-ganyan. Okay. So, for measure of dispersion or spread naman, this will determine the precision of the test. Okay? For the range, ito yung value from parang included yung lowest value to the highest value. So, that's the range. Okay? So, for the SD naman, okay. So, this is the ito yung the most commonly used statistics in the laboratory describing dispersion of the groups of single observation. Ayan. So SD, part pa din siya ng descriptive, isang variable, and then you're going to determine the spread of the data. Okay, based on the levels of SD present in the chart. Okay? So for COV or CV, coefficient of variation, how are the data vary from one another. So ganun lang yun lang yung dinidetermine nito. Since CV is a total percent error, it is expressed in percent. So SD divided by the mean times 100, kaya tinatawag siyang total percent error. Okay. Variance naman, called the SD squared or the SD squared. So SD times SD, ganun lang ibig sabihin nun. It is a measure of variability. So basically, it also measures the precision of the test. Okay. Measures of shape. Gaussian distribution. Okay. Shows the distribution of values by plotting the assay values obtained in the x-axis, actual value, and the number of times each value was seen in the y-axis. Okay. Nasabi ko na ba yung mnemonics sa inyo dito? Meron tayong mnemonics dito axis and DOI. Okay. You will not only use this in chemistry, you will encounter this again in hematology, especially when you do RBC histogram sa RBC counting ganyan or sa RBC parameters. Ito yung ibig niya sabihin. Wait lang. Axis. Axis. Na axis means abscissa. Ano ba yung abscissa? Abscissa. Ganyan, abscissa, x-axis, independent variable, and size of cells. Axis. For ano naman, endoy. Endoy. Number of cells. Huwag niyong kalimutan to hanggang board exam na to. Number of cells. Number of cells. Dependent variable. Coordinate. And y-axis. Yan. Ito yung ano yan. Ito yung ibig sabihin dito. Okay. So, the normal distribution is bell curve. Ibig sabihin nun, once daw na-plinat mo yung mga values and it presents a bell curve, ibig sabihin nun, the data are the data is well distributed. Okay. In the normal curve, the mean, median, and mode are very close. So, ano ibig sabihin kapag the mean, median, and mode are very close? Ibig sabihin nun, it's very precise, as in super precise siya. Kasi magkakalapit lang. Okay. So, sa tatlong SD, the 1SD, 2SD, 3SD, ito yung kanyang ibig sabihin. Okay, based on this bell shape graph, ang ibig sabihin nito, ito siya. So, ibig sabihin nun, dito, 68.3% of data, if 68.3% of data fall between between positive 1 SD and negative 1 SD, if 95.5% of data fall under negative 2 SD and positive 2 SD, and if 99.7% of data fall between positive 3 SD and negative 3 SD, ang ibig sabihin nun, the data are close to each other, the mean, median, mode are close to each other. Okay? Ito yung ibig sabihin ng bell-shaped curve sa Gaussian distribution. Okay? Inferential stats naman tayo. Okay, t-test. Kapag sinabing t-test, ano yung pinaka-notable dito? Dalawang mean. Pag t-test, mean. Merong mnemonics dito TAM SPF. TAM SPF. O, TAM SPF to. T-test, average mean, SPF. Ano yung isa? F-test. Ito yung ibig. TAM SPF. Ito yung mnemonics dyan para hindi ka malito. Tawag dito. T-test, average, mean, tapos yung S dito. Yun, SD. TAM, SD, yung P, forgot the P. Yung P, percent. I forgot the P. Basta yung P, tapos, ano yung F? F-test. Ayan. Kapit ako na yung P. Proportion yata to. Average. TAM SPF. Test. T-test. Average mean. SD. I forgot the P. Wala na nakalagay dito. Basta I forgot the P. Basta merong P. May P dyan. Yan yung ibig niya sabihin. Okay? Yan yung TAM SPF. Para lagi kasi na pagbabaliktad yan. Kapag sinabing between two means, mapapaisip ka, is it F-test or T-test? So, TAM SPF lang yan. Okay? So, one-way ANOVA, ito yung one-way ANOVA, dapat between 3 or more. Pearson. I forgot. Hindi ko lang sure kung Pearson yung P. I'm not sure. Hindi ko naman wala na. Matagal-tagal na kasi. Matagal ko na itong narandaan. Hindi ko lang sure kung Pearson. Pearson, siguro Pearson. I forgot. May Pearson ba dito? Pearson. Tingnan ko later kung mahanap ko yung mga notes ko noon kung meron pa. Okay. So, one-way ANOVA, between 3 or more groups to be examined. Kapag naman sinabing two-way ANOVA, 3 or more related samples. Okay? Huwag niyo kakalimutan yung kanilang difference. Kaya di ba sa research, kapag nagka-compare kayo ng dalawang variable, hindi siya pang ANOVA. Kapag 3 or more, ginagamitan siya ng ANOVA. Like, what is the significant difference na ganyan-ganyan? Like, what's the significant difference? Significant difference at 0.5 na ganun-ganun sa research. Do you still remember that? Ganun. Method selection. Naulit lang din, accuracy, how close to the true value, precise, how reproducible it is, for, ayan, dito pala sa precision. SD, CV, and variance are computed and used as measures of precision. Since ano sila, they determine the spread. Mas spread kasi yung data, hindi siya precise. Kapag mas close sila, kapag hindi masyadong spread, mas precise siya. So kung ano lang ibig sabihin ng measure of spread. Kapag mas malalapit yung value, mas precise. Pag masyadong spread, masyadong magkakalayo, hindi siya precise. Okay? Generally, a CV should not exceed 5%, although for enzyme measurements and immunoassays, a 10% is acceptable. Okay? So dapat yung percent error, total percent error for ano, wait lang. Yan, total percent error. The total percent error for precision must be 5% lang. Ang ibig sabihin nun, kapag yung total percent error is above 5%, ibig sabihin nun, hindi na precise yung method na ginagawa. Okay, kaya dapat 5%. Pero bakit mayroong exceptions sa enzyme measurements and immunoassay? Okay. So guys, ano kasi, these types of measurements, they are, tawag dito, an error exceeding 5% is acceptable kasi medyo ano siya medyo, tawag dito, the sensitivity and stability of the test, hindi siya, medyo sensitive siya, ganun. Kasi nga, enzymes, like for example in enzyme studies and immunoassays, medyo madaming factor to consider. Kaya madaming error na pwedeng mangyari. That's why 10% is acceptable as the total percent error. Okay? Sensitivity of detection, like diagnostic sensitivity, sensitivity of the method. How sensitive is the method? Okay. Ito pa lang sensitivity of the method and sensitivity of detection. Yung sensitivity of detection, parang malapit lang din siya sa sensitivity of method. But for the sensitivity of the detection, just like I said earlier, kung gaano kadami or yung level of analyte present only on the specimen, doon ka lang makaka-detect ng isang analyte. If below that sensitivity index, hindi mo na ma-detect or hindi ka na magkakaroon ng any significant result sa sa specimen. Yeah. The specificity of the test, it measures how many truly negative individuals there are in a population without a disease. PPV and NPV. This refers to how good is the test in predicting which individual have the disease. Ayan. Ano to? Meron tong separate equation, tong PPV and NPV. Okay? So parang yung equation niya, derived lang siya sa diagnostic specificity and diagnostic sensitivity. Okay? I-discuss nyo lang yan sa lecture ninyo later with Sir Ronnie, yung PPV and NPV. Okay? Efficiency of the test or test efficiency. Gaano ba ka-efficient yung test? Efficient ba siya to detect the analyte if the patient has the disease? Yung test ba na yon hindi siya makaka-detect ng analyte of interest if the patient do not have the disease? So, kung gaano ka-efficient yung test, that is highly correlated on how reliable it is. Ganyan. Okay? Huwag niyo kakalimutan yun. Okay, so QC charts. QC charts tayo. Gaussian, yung bell curve. Okay? QSUM. QSUM calculates difference between QC results and the targeted value. What's the major downside of QSUM? It requires computer implementation. Huwag niyo kakalimutan niyo. Okay? Ito yung pinaka-notable kay QSUM. It requires computer implementation. This plot will give the earliest indication of systematic errors and can be used with the 1S rule. Take note din ito. This plot will give the earliest indication of systematic errors. U-den or twin plot. Ito yung chart na dalawang square. Merong malaking square, merong maliit na square. Okay? Kaya siya tinawag na twin plot. Okay? So used to compare results obtained on a high and low control serum from different laboratories. Okay. So saan ginagamit si Euler twin plot? Ginagamit siya sa benchmarking. If you're going to compare or if you're going to benchmark your results along with the other laboratories, you're going to use the Euler twin plot. Okay? Huwag niyo kakalimutan yun. Euler twin plot for benchmarking, compare results from different laboratories. Okay. Next one, the Schuhart or the LJ or the Levy-Jering chart. It is the most widely used system in the clinical laboratory because the meddex is capable to apply rules without the aid of a computer. Ayan. So yung activity 5 ninyo, that's basically a Levy-Jennings chart. Okay, yun yung Levy-Jennings na sinasabi natin. The control results are plotted on the ordinate, time on the abscissa. Ayan. Ordinate, C, ano daw? The control results are plotted on the ordinate. Or on the ordinate, ito yung say, control results. And then time on the abscissa. So if you're going to analyze it, see time is the independent variable. And tawag dito, the result is the dependent variable. Okay. Bakit dependent variable si result? Kasi, uh, kasi the result is dependent on the solution, it is dependent on the other factor. But for the time, it is independent kasi it isn't affected naman. Kaya independent siya. Okay? So from that axis endoy, madami kayong pwedeng i-analyze something. Okay, huwag niyo kalimutan na. The mean value of the control is duplicated by solid line while the control limits are indicated by the interrupted or dotted lines. Ayan. So ganito yung yung nasa activity ninyo. Okay. I-compute nyo muna yung SD ng value and then ipa-plot nyo dito. And then itong mga dots na yan, ito yung mga individual values. Okay? Ito yung mga individual values na nakalista, naka-table. For example, si value 1, ito yung value 1, value 2, value 3, value 4, value 5. Or result 1, result 2, result 3, result 4. Ganyan. Plot nyo dyan. Okay? Ano yung ibig niyang sabihin? How do you interpret a Schuhart or LJ chart? Ano yung itsura niya? Trend. Saan nakikita ang trend? Systematic error. Deterioration of reagent, improper calibration, failing instrumentation. Ganito yung mangyayari. This is a trend. Sabihin nun, 6 or more consecutive values either decrease or increase in consecutive days. Yan. So ito yung 6 na consecutive days, papataas ng papataas yung value. That's basically a trend. Pwede mag-deteriorate, pwede merong failing instrumentation. So yung mga mga tawag dito, yung parang may gawin doon, kapag nag-deteriorate yung reagent, you're going to open a new batch of control solutions na. Ganyan. So nakita ang trend sa systematic error. For shift naman, okay, shift is seen in random error. From the word itself, shift, parang biglang nag-shift, parang nagkaroon ng random result na masyadong malayo sa general calculation or sa mean. Okay? So sudden change in analytical process or random error formed by control values that distribute themselves on one side or either side of the mean for 6 consecutive days. Ayan. So ito yun. Okay? Usually indicates improper calibration of instrument. Okay? Trends and shift, pwedeng magkaroon ng trends and shift kapag merong systematic error or pwedeng merong random error. Okay? So depende yan sa case. Okay? So for trend and shift, usually they are tawag dito? They are the effects of systematic error. But for trend kasi, systematic na siya agad. But for shift, usually indicates improper calibration of instruments and that falls under systematic error as well. Usually indicates but not all. Okay? So, ito, shift in the reference range is due to the transient instrument differences. Outlier naman tayo. Outlier is, tawag dito, outliers are indicated by random or systematic, but commonly random. Tingnan niyo yung chart dito. Randomly, merong isang outlier. Parang merong isang nag-fluctuate sa mga values. So that's basically a random error. Okay? Pero it can also be caused by systematic error as well. Okay? So depende yan sa itsura ng chart. Depende yan sa cause ng problem. Okay? So you can determine it. Okay? So an analytical method is considered in control when there is a symmetrical distribution of control values about the mean around the mean where there are few controls outside the 2SD control limits. Ayan. Ano yung acceptable limit? Acceptable ring, acceptable SD. Dapat lahat ng values nasa loob ng 2SD. Okay, para in control yung test process. Kapag meron na magpas ng 2SD, hindi na in control yun. May mga errors nang nagaganap. Okay? So what is a Westgard rule? Okay. Dito tayo sa Westgard rule. Error detection rates can increase without increasing the false rejection rate. Pinaka-important dito. Error detection rates can increase without increasing the false rejection rate. Kasi yung ibang chart like the yung QSUM ganyan, kahit simpleng error na ma-detect, the whole data or the whole run is rejected na. Since hindi naman yun economical and hindi siya practical, the utilization of QC chart like LJ can prevent it from happening. Para hindi tayo reject ng run. Kasi mahal yung control, mahal yung control, mga reagent, mahal naman. So dapat we must consider it also. Okay? So used to accept or reject a run of samples. First rule, 1-2S. Ang ibig sabihin ng 1-2S, there is a one control beyond the 2SD. Ayan. One control value outside or exceed the 2SD from the mean. I-reject ba natin? Hindi natin siya i-reject because 1-2S is a warning rule. Kapag sinabing warning rule, ibig sabihin nun, kapag hindi mo kinalibrate yung instrument mo after running this control, malaki yung chance na magkakaroon ka na ng mga other violated rules later. So, ito yung itsura niya, di ba? Ayan. Ito yung 1-2S. Ibig sabihin nun, there is a one control value outside the 2SD. Ayan. Either yan or yan, it's the same. They are 2SD. Tawag dito. They are 2SD violation. Next naman is 1-3S. One control outside or exceed the 3SD from the mean. This is a random error. Kasi nga sobrang layo niya sa mean eh. Ito yung mean, yung nasa gitna. Sobrang layo niya. This is a random error. Okay? So, i-reject ba natin or i-accept? Kailangan nang i-reject kasi sobrang outlier na siya. Okay? So, this type of rule must be rejected and it is a random error. Kaya nga, sabi ko sa inyo kanina, you can actually see kung anong type ng error yung nasa chart based sa kanilang plotting. Kapag masyadong malayo yung isa, basically parang random lang yun. Kapag may pattern, may trend, may pababa, may pataas, nasa iisang side lang ng mean, nasa positive side lang ng mean, nasa negative side lang ng mean, basically that's a systematic error, ganyan, or calibration problems, or failing instrumentation. Ganyan. For R4S, from the words of R4S, this is a range violation. Ibig sabihin ng R4S, yung gap ng dalawang value for yung range nila, for yung gap. Okay? Ito yung ibig niyang sabihin. For example, yung itong dalawang value na to, sobrang layo ng kanilang gap. Okay? Yung isa, beyond 2SD, yung isa beyond 2SD. So, bilang tayo, 1, 2, 3, 4. Okay? So, parang 4 tawag ito? Basta 4 yung gap from one value to another. Dapat magkasunod ha. Yung magkasunod na value, parang 4 yung range nila nasa 4S. Okay? So, yun yung ibig sabihin. So, this is a random error as well. Random error siya kasi nag-fluctuate randomly. Diba? Gets nyo ba? Nagganyan lang siya. Okay. Next one. For 1S, ibig sabihin nun, the four control values or the four control measurements are on the are on the 41 are on the 41S. Ganito yung ibig niya sabihin. Okay. Nasa 41 nasa 1S yung apat na value. Hindi yan pwede. Ano ba kasi yung normal na run ng isang library joining? Dapat tumataas bababa, taas baba, taas baba. And dapat nagro-rotate lang sila sa mean. Kapag meron yung isa na nasa isang side lang, that's basically a violated rule na. Okay? So, yung ibig sabihin naman. 10x. 10x, 10 consecutive values on the same side of the mean. May pattern. May trend. Nasa isang side lang. So, basically, this is caused by a systematic error. Ayan. Tingnan nyo yan. 10x rule violation. Reject the run. Pag ganyan na yung na may measure na control. Reject the run. Okay. Next one naman, 6x. Parang 10x lang din, pero yung result is 6, yung isa kanina 10. Ganun na yung sabihin nun. Kaya 6S, rule violation. Ito yung updated kasi sa book ni Suba, tapos sa ibang materials, 10x pa lang yung nakalagay. But yung updated from the site of Westgard rule kasi may mga bago ng rule like 6S rule, like 12x rule, mga ganito yung mga 12, ganyan. Kasi bakit 6x? Kasi kapag nag 6x na yung run, parang i-reject mo naman na. Gets nyo ba? Kasi kung 1, 2, 3, 4, 5, 6 na ganyan yung nakita nyo, reject na yan. Pero kung ganyan na, parang medyo hindi nyo napansin. So, naipon yung dito, yung mga value sa isang side ng mean. Also for the 9x rule, same lang din. Pero 9 yung value. Okay, ito na. 2 of 3s. Ibig sabihin ng 2 of 3s, 2 out of 3 control values, control measures exceed the same mean plus 2s or mean minus 2s control limit. Ayan. Paano yan naging 2 of 3s? Ganito yung 2 of 3s. Ibig sabihin nun, 2 out of the 3 control measurements, ibig sabihin, if you're going to measure 3 controls consecutively, nag-exceed siya ng 2s or mean minus the 2s control limit. So, hindi yun pwede. Okay? Reject na din agad yan kapag ganyan. Though, nagde-deviate naman siya, tumaas, bumaba, pero the two out of the 3 values are located outside the 2SD. Kaya tinawag na 2 of 3S. 2 of 3 2S. Okay? So that's the 2 of 3 2S violation. 70. Systematic or random. Kahit hindi mo naisipin, it's basically a systematic error. Okay? May trend. Papataas na yan. So that's at 70. Or the T stands for trend. Hindi ko alam kung trend yung stands for nun. Pero parang trend kasi yan. So that's 70. Ayan, control values that suggest random error and systematic error. 1, 2S, 1, 3S, R4S, 2, 2S, 4, 1S, 10X. How will you understand this? Di ba kapag mga odd numbers, they are random error. Kasi nga, parang this value fluctuates randomly. Kaya, paiba-iba lang siya. Parang yung isa nandun lang sa isang side. Kanya. For systematic error naman, it needs a pattern. It needs a trend. Dapat may pattern yan. Kaya, even number yung mga yan. Hindi pwedeng 1, 2S is a systematic kasi you cannot see a systematic error with just one value. You must need at least 4 to 10, mga madaming value to see a pattern. Because you cannot see a pattern in a random error kasi parang randomly lang siya. Okay? So, ganun yung ibig sabihin. If any one rule indicates a rejection, the run should be rejected, and if none of the rules indicated the rejection, the run should be accepted. Okay? So the combination of the control rules used in conjunction with the control chart has been called the multi-rule Shewhart. Okay, yan si Shewhart. Madali lang yan. Okay. Other terms for quality control. Dito na sa other terms. Okay. So, the delta limit, cumulative summation, critical limit. Dito tayo sa critical limit. Critical limit are panic value. Parang they have the same idea. Used to define where when medical intervention is likely needed to prevent injury or death. Okay. Significant change limit. Dapat normal physiological and analytical variation. The difference in test result that is medically significant or that which cannot be attributed to the sum of normal physiological and analytical variation. Okay, Six Sigma. Lumabas sa board exam namin. Tawag dito. I forgot the mnemonics about this. Nasa Henry, ay nasa Bishop itong Six Sigma sa quality assurance. Yung ano kasi, yung tawag dito, yung purpose ng Six Sigma, this is to prevent or to know kung meron na bang nangyayaring error sa system. Ayan. So that's Six Sigma. Ano yan eh, may ano siya, I forgot, sorry. You just need to read Bishop if you have the time. Analytical run, ito yung test. Delta check. Okay. So delta check, ito yung sinasabi ko sa inyo kanina. Bakit kailangan yung mga specimen natin merong date and time of collection. Okay? Kasi guys, if you're going to do the delta check, ito yung you're going to compare the result of the same patient with different dates of collection and testing. For example, nung Monday, tinest mo si Juan de la Cruz. Yung kanyang electrolyte is mata. Yung kanyang electrolyte for sodium is mababa. Tapos, tinest mo ulit kinaumagahan mababa pa din. At some point, you have this idea na ay talagang mababa din talaga siya. So, parang i-correlate mo siya. Yung test niya from yesterday, ganyan. Also for HEMA, for example, dengue si patient, ganyan. Yung example ko kanina, yung platelet count niya mababa. Nung una mong nakita yung platelet count niya, mapapaisip ka, may clot kayo yung specimen. Pero nung tinignan mo yung kanyang patient diagnosis, tapos tinignan mo yung kanyang delta check o yung kanyang CBC kahapon, ay talagang mababa din talaga. Okay? Sign the result, release the result. Ganun ibig sabihin. Okay? So that's why delta check is it is the most commonly used patient-based quality control technique. Okay? Parang ipapattern mo yung resulta mo to the other testing date. Ganyan. Okay? Huwag niyo kakalimutan yun. Interference specimens. These are interference. They are analytes, they are components, they are materials that are interfering the testing process. Hemoglobin. Kapag na-hemolyze yung specimen sa serum o sa plasma, magkakaroon ng mataas na level ng hemoglobin. Lipids, kapag natapos kumain ng patient, turbid yung sample. For bilirubin also, color yellow. Itong tatlong ito, saan siya common nag-i-interfere? They are commonly interferent. They are a common interfering agents in colorimetry assays, in colorimetry test. Kasi may mga kulay yan. Kapag hemoglobin, nagre-red yung plasma or serum. Kapag lipids, nag-o-opaque o nag-yellow or parang opaque, ganon. Kapag bilirubin, nag-yellow siya. Kapag may ganyan yung specimen mo, tapos colorimetry yung testing method, magiging efficient ba? Mare-determine ba ng machine yung proper color kapag may color na talaga yung specimen? Hindi. Okay? That's why they are interference. Okay? Also, for hemoglobin, kapag magtitest ka ng total protein, tapos hemolyze yung sample, since hemoglobin is a protein itself, pwedeng mo overestimate yung total protein kasi madaming hemoglobin. Okay? Mga ganun lang. We will discuss that later in other topics also. Anticoagulants, preservatives, interferences, and then carry over issue, anticoagulants and preservative. Yan. Linear range, physiologic limit. Ito yung sinasabi ko sa inyo kanina. When we say physiologic limit, ito lang yung limit na acceptable. For example, yung glucose ni patient is 500 milligrams per deciliter. Sobrang taas na nun. Well, physiologically, hindi siya umaabot ng ganon. Physiologically, walang ganon na value. Pero in some diseases or in some conditions like hyperketotic, hyperketotic diabetic coma, yung mga may ganong condition, umaabot ng 500. Yan. Ano pa yung isa? Para absurd yung value kapag nag-collect ka ng sample sa site na merong IV line, na merong D5W or dextrose 5 water. Hindi ko lang sure kung dextrose 5 water, basta D5W or DW5. Kasi kapag nag-collect ka ng sample for glucose sa merong site na merong IV, and then yung IV is merong glucose solution, as in, sobrang taas din talaga ng glucose niya. Ganun lang yung ibig sabihin. So parang mapapatanong yung medtech na bakit sobrang taas naman. Parang hindi naman to posible. So that's what we call absurd value. Okay? So what are the other examples also of absurd value? They are part of the process. Contaminants, contamination or dilution, inadequate reagent volume, saka din major problems with the method or incorrect recording or transmission of the result. Ayan. Ito yung sinasabi ko sa inyo kanina. Incorrect recording or transmission of result. For example, imbes na 90 to 100 milligram, 110 milligrams per deciliter for FBS, ang nasulat is 90 to 110 millimoles per liter. That's absurd. Okay? Absurd na yon, kaya hindi yun acceptable. Okay? So, itong physiologic limit, it is commonly encountered in the testing process. Contaminants, inadequate reagent volume. Kasi ibig sabihin nun, yung reagent mo, konti, tapos madami yung sample na nilagay mo. So basically, it will be overestimated. Ganyan. So magkakaroon ng mga absurd values. Ganyan. POCT. Dito si POCT, point of care testing. Okay. So the goal of POCT is to make testing decentralized. Okay. Kapag sinabing decentralized, hindi na lang sa laboratory ginagawa. Hindi na lang sa laboratory ginagawa ang testing. Okay? So what is the most commonly encountered POCT kit sa mga bahay-bahay? They are the glucometers. Okay? Ito yung mga glucometer na gumagamit ng capillary blood sample para sa mga monitoring ng mga patient na merong diabetes, ganyan. Okay? So, ayun. Usually by non-lab personnel. So, yung patient mismo, he can do it or she can do it by herself or himself sa kanilang bahay, ganyan. So, what are the other names of POCT? Near patient testing, decentralized testing, bedside testing, and alternate site testing. Okay? Okay. So, QA. QA naman tayo. When we say quality assurance, we are ensuring quality. Okay? What is the philosophy of QA? Quality is important to customer. From that alone, dapat quality na talaga kasi hindi pwedeng mag-release ng resulta na out of quality. Okay? Know this one. What is the tripod of QA? Program development, assessment and monitoring, and quality improvement. Yan, tatlo yan. Kaya nga siya tripod. Okay? QPC or quality patient care. When we say quality patient care, from test requests, from fasting, patient prep, from the running of the method, from the releasing. So kapag na-meet mo lahat ng standards from all those phases of testing, basically the delivery of healthcare to the patient is of standard din. So tama ang treatment plan, tama ang gamutan, ganyan. So that's the process. Okay? Para maging smooth yung flow ng healthcare team sa isang clinical setting, ganyan. Okay? So recovery specimen, it will show whether a measure all the analyzed or only a part of it. Okay? So parang recovery specimen, recovery specimen parang part siya ng specificity, but it's a parang for example, if you're going to determine albumin only, dapat albumin lang. Hindi ka makaka-detect ng other proteins like yung mga other proteins. So basically the recovery, if you're going to determine the analyte only and not the other types of analyte based on the bracket. Okay? Ganun yung ibig sabihin. How to make a reference range or reference interval usually involves from healthy population. Okay, so lahat ng lab dapat merong reference range. Kapag gagawa ka ng reference range mo, ito yung mga dapat gawin. Okay? So to derive reliable estimates of a reference interval, at least 120 individuals or 120 replicates yung gagamitin mo. Okay? Should be tested in each age and sex category. Bakit kailangan stratified siya? Bakit stratified siya based on age and sex? Kasi guys, there are certain analytes na mas mataas sa male, tapos mas mababa sa female. Diba? For example, for uric acid sa male, mas mataas, mas mababa sa female. RBC count for male is mas mataas, mas mababa sa female kasi meron silang menstrual cycle. Ganun. Mas mataas ang hemoglobin ng male compared sa female. Mas mataas ang creatinine sa male kasi sa muscle mass ratio compared sa female. Ganun. So basically, the establishment of reference values or reference ranges must be stratified into age and sex. Okay? Also for the age, there are certain analytes na mataas in an age bracket compared to the other age bracket. For example, for uric acid, mas mataas yung bracket niya for 40 pataas. Ganyan. Okay, mga ganon. For example, for alpha fetoprotein, mas mataas ang count or mas mataas ang value sa mga newborn compared sa teenager. Ganon. Basically, that's it. Okay? You need to base all your analytes and stratify them on age and sex category. Okay? Okay, so yeah. So however, all the 20 reference individuals need to be tested for analysis on the test instrument if the laboratorian determines that the test instrument and test population are similar to those described by the manufacturer's package insert. Ayan. Since ito kasi guys, hindi na ito common na ginagawa. Hindi na yan common ito. Ito, pwede itong gawin. Itong 20 reference intervals na lang. From 120, if wala kang basis. But if you have the basis na, you can use 20 replicates or 20 reference individuals. Okay? Yun yung ibig sabihin niya. The manufacturers reported 95% reference limit may be considered valid if not more than 2 of the 20 tested subjects fall outside the original reported limits. Ayan. So, parang if you're going to relate dito the Gaussian bell curve, ganon din yung ibig sabihin. Okay? Okay, ayun na. Tapos na pala siya. Ang tagal ng lecture na. 3 hours. Okay, so yun lang. May mga tanong tayo dyan. Meron naman na kayong head start nung binasa nyo itong module. So basically, meron na kayong konting idea. Okay. Clean ko lang para hindi kayo masyadong mahirapan sa exam. Okay guys, good luck sa exam ninyo. By the way, yung wala pa yung schedule ng exam, mag-decision na kayo kung anong day, anong time. And then, for bacteriology, since binigay ko na yung mga module and notes for 5128 or A1 to A1 sa group chat, sa mga ibang sa mga ibang code ng Bactilab, you may as well share your modules na binigay sa inyo ng inyong mga instructor kasi departmental kasi yung exam. Ang mangyayari, I will be giving 50 items. Ma'am Blade will be giving 50 items. Ma'am Nidia 50 items. And randomly, we will just select kung ano yung gusto namin kunin. So dapat medyo alam niyo lahat para hindi kayo ma-space out, ma-blank sa exam ninyo later. Yun lang. May mga tanong pa tayo dyan?
Sir, ano daw po yung ginagamitan ng graphing paper?
Ayun din, ito. Pwede nyo gumamit ng graphing paper. Yung LJ chart. Pwede nyo gamitan yun. Okay? Sa activity ninyo, pwede nyo i-print yung file and then sa yung sagutan. Print yung file. Doon nyo na lang sagot. I-print nyo yung file na merong chart. And then kapag i-scan ninyo, didikit nyo na lang yung chart na yon sa may activity format. Ganun. Be creative. Hindi naman ako masyadong stick sa mga paggawa ninyo kasi medyo mahirap na din naman. Unlike if you have the lab manual itself na madali lang siyang gawin. Okay. May mga tanong pa tayo dyan?
Sir, sa interpretation po ba, so divided yun sa tatlo, yung trend dun po sa activity kung saan. Parang
Um,
ganyan po ba na divided sa tatlo?
hindi ko na pansin. Basta interpret lang. Basta sabi interpret. Sabi, may trend bang naganap? May shift bang naganap? May mga na-violate bang rule? Mga ganun lang. Kung walang na-violate na rule, like sabihin nyo na there is no violated rule, ganyan. There is no trend. Kung may trend, there is a trend between this value to this value, ganyan. There is an outlier. This value is the outlier one, ganun. Ganun lang yung interpretation. Make it simple, pero significant yung mga ano.
Sir, last. Sir,
Okay.
clarification lang ito for me. Kapag may isang rule na yung nare-reject, for example, is 32S, ay 31S, ganun, or 13S na naganap, kahit isa lang, sir, reject na lahat.
Reject na yun.
Ah,
Reject the run. Okay.
thank you, sir.
I-reject na yung run na yun. Okay, ganun. Reject when, parang ito din. Kasi lahat ito reject. Lahat ng rule na to, pag merong ganyan, that is all rejected except sa 1-2S because it is a warning. Accepted pa din ito. Kapag nag-card kayo ng 1S, the run should be accepted. Ganun lang. May mga tanong pa tayo dyan? Wala na? Okay. So yun lang guys. Good luck sa exam ninyo. Talaga na mabuti. See you sa face-to-face again. Next week.
Thank you, sir. Bye, sir.
Okay, sige.
Thank you, sir. Bye po.